चेक करो एक बार जाके। हेलो हेलो हेलो। हाँ रिक्वायर्ड नहीं आ गया। ठीक है ओके। हेलो 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 हेलो। So good evening students. I hope I am audible, I am visible. I If you can just type, I know that I'm late, stop typing late. Just let me know if I'm audible and visible. Hello hello. Okay. ठीक है. So this has been a very successful series. We are getting like amazing views in all the lectures. There's very great support from students across PW Tamil Nadu, and it's great to see the participation. It's great to see the participation. I hope I'm audible. Yeah, okay. So the previous two lectures have got a lot of views. Okay, so let's continue. I'll expect that the same support will continue this session also. So today's session is not going to be very lengthy. So in this session, what we are going to do, like there are certain topics where what happens that like those topics are towards the end, so we tend to skip it. We don't practice those many questions from those topics, and it's kind of an element of surprise in your JEE main exam. There are many topics where JEE main mentions that it is not in syllabus, but somehow some question you will definitely see in some one in other form in your paper. So those kind of questions will be taking. You know that this year the pattern has changed. You will not have 30 questions one option. You will have 25. Every single question you have to attempt. There is no option. So now keeping that in mind, there are certain typical problems where what happens that we don't generally practice a lot in class. So if you see those questions in exam, you might panic, you might tend to leave them. So today we'll be practicing those kind of questions, and you know, like we already have, like we have, like we have seen many topics such already in the class. Like I'll just tell you the name, like the log series, the exponential series. Now we don't generally practice a lot of these series questions, and that is not required. But you see, in JEE main, they have a certain pattern, and they keep asking same question again and again, right? So some questions from exponential and log series will be taking. Then after that, we will be taking some questions from Cramer's rule in data in matrices. Then there are some reduction formula problems. Those questions will be taking. So number of questions are not much, but whatever questions are there, these questions are basically the element of surprise in your JEE main exam. So once you see the paper, you won't feel like after this session that there is a new question which you have never seen. So like in PNC, you know, from 2023, a lot of questions are there from non-negative integral solution methods. So those we will be discussing, especially where the multinomial is involved. Okay. So again, just to inform you that it is not the complete PYQ session, only the problems which might be an element of surprise in your JEE main exam. Okay. So we'll start our session. We are going to start our session. Just give me a moment. Just give me a moment. Okay. Fine then. So let's start. Okay, so the first thing that we are going to do is the logarithmic series and the exponential series. Okay, so this e to the power x, we know this is how we expand 1 plus x plus x square by 2 factorial plus x cube by 3 factorial x power 4 upon 4 factorial, and this will tend towards infinity. This is how we write e to the power x, right? Now if I put x equal to 1 here, in this entire series, if I put x equal to 1 here, you see, so what is e basically? 1 plus 1 by 2 factorial plus 1 by 3 factorial plus 1 by 4 factorial, and this will go to till infinity. Clear? Now, in the same series, like let's say, if we put x equal to minus 1, this is for x equal to 1. If I put x equal to minus 1, so e power minus 1 will be 1 minus 1, then plus 1 by 2 factorial, minus 1 by 3 factorial, plus 1 by 4 factorial, minus 1 by 5 factorial, and the series will continue towards infinity. Got it? So now using e power 1 and e power minus 1, there are certain results based on which you will see problems. So those results we can see from here itself. So this is what e looks like, this is what 1 by e. So you see this 1 by e term, this 1 by e term is like 1 by 2 factorial plus minus 1, minus 1 by 3 factorial plus 1 by 4 factorial minus 1 by 5 factorial up to infinity. Okay, this is the series. So now if I treat this thing as equation 1 and this thing as equation 2, fine. Now if I add e and 1 by e, what is going to happen? Or before adding, let's see, how can we write that in the form of an expansion? You see 1 plus 1 plus 1 by 2 factorial. Before we go ahead, let's write this as a sigma notation. In the form of sigma notation, we'll write it as a general term. Like how will you write it? This, what is this e is basically? This e is sigma of, this is, let's say 1 by n factorial, where n is from 0 to infinity. Is that clear? So wherever you see this term, wherever you see 1 by n factorial ka term, immediately it should strike that this has something to do with e. Similarly, if you see for 1 by e, 1 by 2 factorial minus 1 by 3, 1 by 4, minus 1 by 5, you can write. Is that clear? So this 1 by n factorial, when you put n equal to 0, 0 factorial is equal to 1. Now when we write these negative terms, okay, let's say we have minus 1 ka factorial, minus 2 ka factorial, so that we have to ignore, we have to take only for the positive ones. So now if I consider that as something like equation 1 and 2, okay, so now in this, now if I add these two, okay, if I add e plus 1 by, you see what is going to happen. If I add e and 1 by e, you see what will happen. This will be 1 plus 1, 2. So 2 plus, this will be twice of 2 by 2 factorial. Then 1 by 3 factorial, this particular term, you see, this particular term will cancel out. 1 by 3 factorial minus 1 by 3 factorial, these two will cancel out. All odd terms will cancel out. So what we are going to have? Only even terms here, even factorials in denominator. So this will be 2 plus 2 by 2 factorial, 2 by 4 factorial, 2 by 6 factorial, 2 by 8 factorial, and this will continue up to infinite. Clear? This will continue up to infinite. So this e plus 1 by e upon 2 will be 1 plus 1 by 2 factorial plus 1 by 4 factorial, 1 by 6 factorial, continues up to infinity. So now we have to write this also in the form of sigma. So in form of sigma notation we can write. So what exactly this can be written? This will be sigma n equal to 0 to infinity and 1 upon 2n factorial. This is what we can write 1 upon 2 in factorial. So in exam, basically what you have to observe, this is what you have to observe, right? You will see only even factorial in the denominator, you will see only odd factorial. So now when we have added e plus 1 by e by 2, you see we are getting 1 upon even factorial when n starts from 0 to infinity. Now similarly, if you want to have odd factorial, you know what to do. You exactly know what to do. If you want to have sigma 1 upon 2n minus 1 ka factorial. If you want to have this in the series, what exactly we have to do? We have to subtract, you see, e and 1 by e. If I subtract these two, you can understand what will happen. You will have 1 by 3 factorial, 1 by 5 factorial. This will remain. So this will be twice of 2 plus 2 by 3 factorial, 2 by 5 factorial up to infinity. Is that clear? This is what. So the main thing is that now in exams also, I hope I am audible, visible. Okay. Yeah. So in exams also, what you will observe from options is it will be already mentioned. It's not like that you have to use a lot of brain to understand that this is exponential series. Options may be mentioned. Yeah, option is something multiple of e, 1 by e, 2 by e, like that. Right? So you don't need to have a separate method to identify. The question is already identified that this is from exponential series. So this you have to remember 1 by 2n minus 1 factorial, 1 by 2n factorial, and again the result, it will take hardly 10 seconds to derive. I'm not saying to mug it up, but the result itself, it will take hardly 10 seconds to derive. So either 1 by odd factorial or 1 by even factorial, okay? Then we have log also, like these log terms. So what exactly is log 1 plus x? So log 1 plus x is x minus x square by 2 plus x cube by 3 minus x power 4 by 4, and this will keep on continuing. So this is what we have log series as. Now if you put x equal to 1, you see what will happen. If you put x equal to 1 here, you just put x equal to 1. What exactly is this? Log 2 will be equal to 1 minus 1 by 2 plus 1 by 3 minus 1 by 4 and so on. So now again, this is what we have to observe in the exam, right? And again, that if it is a problem of log series or not will be very clear from the options. Like recently, whatever questions have been there in exam from log series or any other exponential series, it is there. This will be there in your like options, okay? So let's start with the problems. I hope you got the idea. Okay, the questions what I have taken, these questions are very recent ones. So the first question I have taken is from JEE Main 2024 only. One of the lengthy problems, but again, you see, this is not something which you have, like which you cannot solve. It is lengthy, that is true. So let's start the simplification here. If you observe this series here, this is 1 plus root 3 minus root 2 upon 2 root 3. So fine, the first term is root 3 minus root 2 upon 2 root 3. Fine. Second term is 5 minus 2 root 6. Okay, 5 minus 2 root 6. Now, if you look at the term, this gives a very clear idea that 5 minus 2 root 6. This 5 minus 2 root 6 is nothing but, if I do this root 3 minus root 2 chi square, this is what I'll get. Right or not? You know, if I have this thing as square, root 3 chi square 3 plus 2 5 minus 2 root 6. So that is what I'll have. This is nothing but root 3 minus root 2 ka square divided by 18. The next term, now see. Now I'm not telling that I'm so sharp that I can tell directly that this is the cubic, but this is how in exam also you will see. They will always give you hint. This was power 1, this was power 2, and this is nothing but power 3. You can cross check, you can verify. You see, when you multiply root 3 minus root 2 with 5 minus 2 root 6, this is what you will get. If you multiply this root 3 minus root 2 and will multiply with 5 minus 2 root 6, you see, this is 5 root 3 minus 2 root 18 minus 5 root 2 and then plus this is plus root 12. So root 12, 2 root 12, that will be 2 root 3. So this is 4 root 3. You can see this is 5 root 3 and root 18. What we can write? Root 18 is, this is 5 root 3. This is root 3. Yeah. So this is root 18 will be 3 root 2. So this is 2 already, 6 root 2. I think it will be there. Right? Root 6 root 3 is root 18. 18 is what? 9 into 2. 3 will come out. Root 18. Now just add it. What is it? This is 9 root 3 and minus 11 root 2. That's it. You see, this is what we are having here. So that was the intuition, and most of the times it is what, like, you will find it that was true. So third term is the root 3 minus root 2 whole cube divided by 36 into root 3, and it will keep on going. So what exactly is happening in numerator? In numerator we have got these squares. Now check for denominator, 2 root 3, then 18, 36 root 3. Like, is there anything else? If you see the pattern here, is this square of it? Not at all, right? So there is still something else which we need to figure out. So root 3 minus root 2, if I separate root 3 from here, 1 by 2. Okay, next term will be root 3 minus root 2 divided by 18 is what? 18 is 2 into 9, right? 2 into 9, or 6 into 3 we can write. So if I write this as root 3 ka square, so this is 3, I'll have into 1 by 6. Got it what I'm trying? I'm trying to have some term from denominator also to include in the numerators ka pattern. So I got it already. I can see that root 3 should be also included. So next one will be what? Root 3 minus root 2 divided by root 3 ka cube into, this is 36 root 3. So root 3 cube is 3 root 3. So this will be 1 upon 12. Right? Root 3 cube is 3 root 3. So 12 is 36 root 3. So now we can see the pattern, what exactly is going on. Clear? So let's consider this root 3 minus root 2 upon root 3 as some element t. Let's call it t. So our series is now 1 plus t by 2 plus t square by 6 plus t cube by 12, and it will keep on going, right? This is how the series looks like at this moment. I hope it is clear. Let me check the chats. I hope the terms are clear. Okay. I hope the terms are clear. T by 2, t square by 6, t cube by 12, and so on. Now, this itself again does not look like a series, correct? This is not a series, right? There is not AP, not GP. But if you observe the denominator terms are product of two consecutive integers. You see, this is 1 into 2, 2 into 3, 3 into 4, right? Next term will be what? 4 into 5. Next term will be, this will be t power 4 divided by 20, and so on. So we have this consecutive terms ka product in the denominator itself. So that can be separated as a difference. Now how will we do it? You see, this will be 1 plus t into, right? 1 by 2 is 1 minus 1 by 2. T square by 6 can be written as 1 by 2 minus 1 by 3. Then t cube by 12, this is 1 by 3 minus 1 by 4. Then t power 4 by 20 as 1 by 4 minus 1 by 5, and keep it going. Right? Now I think you are able to see that series somehow. This log series, now I think you are able to identify. So if I split terms, okay, one series I have in addition, one in subtraction. Now if I split terms here, how exactly it will look like? This is 1 plus t square by 2 plus t cube by 3, t power 4 by 4, and so on, minus. Now if I take negative terms common here, so this is minus t by 2 minus plus t square by 3 plus t cube by 4 and the other terms. Is that clear? Now do you see log series getting formed here? What is log series? We already have seen. What exactly is log series? You see, this is how log series looks like. Now in this, if I replace x with minus x, you see in this, if I replace x with minus x, so this log 1 minus x will be equal to what? This will be minus x minus x square by 2 minus x cube by 3 minus x power 4 by 4 and so on. So if you take negative sign common, if you take minus sign common, so what exactly is this? You see minus sign, if you take common, x plus x square by 2 x cube by 3 up to infinity. So this is the result of log 1 minus x series. Is that clear? So now we'll use the same result in that particular problem. You see 1 plus t square by 2. So t square by 2 t cube by 3 t power 4. Here also t square t cube by 3 t cube by 4. And here we have, with square it is 2, with cube it is 3. So just take terms common, that's all. You just take them common and you are done. So here this is 1 plus, let's take t common. Or this is already in the format, right? This is already in the format. This is 1 minus log 1 minus t. You can see easily, right? Log 1 minus t. This is t plus t square by 2 t cube by 3. From that particular term, what exactly we have to do? This is minus. Okay, this is minus. This is t square by 3 t cube by 4. This is t by 2 plus t square by 3 t cube by 4 up to infinity, right? So this we have converted in the log 1. From here, what we need to do? You see, here it is square, it is 3, t cube by 4, there it is 4. So what exactly it looks like? What we have to do here? This is t power 1 by 2, this is t square by 3, t cube by 4. So what we should do? We can multiply it by t and divide it by t, right? So if you do that, this is 1 minus log 1 minus t minus. So if I take t multiplication and divide it, so it will be, this will be, okay, this is minus, this will be 1 by t, and then it will be, you see, this will be t square by 2 plus t cube by 3 plus t power 4 by 4 and up to infinity. So both the series now we have converted. So then you have to put this result of t and then you have to simplify. Is that clear what we did? Right. Now, if I talk about complexity of such series questions, so this is what it is going to be. You see in the exams, it is about exponential, it is about log series. These kind of calculation will be there. I'm not telling that just by looking at the expression you can understand that this is going to be a log series. It might be difficult, right? But once you write 2-3 steps, after that you can visualize that this is going to convert into that, right? Especially this thing 2, 6, 12, 20. Here we had to identify that the denominators are nothing but written as difference of conjugated terms. Now that will give you a hint. So here also we have that series, here as well we have that term. So after that the calculation is yours, you have to complete the calculation. Next question. Okay, so in all the problems, this is what I am doing. I'll be giving you the complete hint. Okay, in this question you just observe what type of terms we are having in the new denominator. Just look at denominator here. We have 2n factorial, we have 2n factorial, right? And just look at the options. Every single option we have exponential already given, right? So this is very clear that this is a problem from exponential series. So what exactly we know? We had this result that we need 1 upon either 2n factorial or n factorial or n minus 1, 2n minus 1 factorial, right? If you remember the result of exponential series, the general terms which we had written, all the general terms which we had written, it was either 1 upon some factorial, even factorial, or odd factorial, right? Or simple, even if it is 1 upon n factorial, that is also true. Okay, so we have 3 results. One is the only e power 1, e power 1 or e power minus 1. The second result, we have e plus 1 by e third result we have E minus 1 by E. Got the point? So these results we have using, we are going to use them. So let's start the simplification here. And if you observe numerator here, 2n square, 3n, 4, just like binomial. Just like binomial. In binomial, you know, when we write that sigma series, we know that it should be NCR, R equal to 0, 2n, we write 2 power n, right? So the result is for this exact general term. If there is any other variable multiplied here, what do? We remove that, we cancel that. If there is any other variable, let's say sigma R equal to 0 to n, R into NCR. So you have to get this R cancelled. You have to get this R cancelled at any cost. And how to that? Just multiply and just write NCR as n by R, n minus 1 C, R minus 1. Got it? So the same thing. If you want to use E plus 1 by E, E minus 1 by E, you know that it should be the exact general term which we have. No variables in the numerator. Variables are not allowed. By some calculation, we have to cancel the variable out. Right? You have to cancel that variable out. So let's start. Now here we have 3 terms. This 4 by 2n factorial is fine. You see here the last term, this is simply sigma n equal to 1 to infinity 4 by 2n factorial. So this is the very easy to solve. Right or not? We already have final result for this expression. What is 1 upon even factor? You see when you put values here, this is 4 into sigma n equal to 1 to infinity 1 by 2n factorial. So when you start putting values, what do you have? This is 1 by 2 factorial, 1 by 4 factorial, 1 by 6 factorial, and so on. Right? So we know how to write this series as what exactly is this. If you see, if you remember our exponential result, what exactly was that? Sigma 2n factorial. You see, this is our sigma 2n factorial, 1 by 2 factorial. So we have to subtract 1 from there, because in the expression we have only 2, 4, 6, 1 is not there, so that has to be subtracted. So this part is sigma 2n factorial from n equal to 1. We had written from 0. That also you have to see. We had written from 0. So we can replace it. What we can write there? This thing will be equal to 4 times E plus 1 by E by 2 minus 1. So fine. This term we can evaluate, right? Now 2n square and 3n, the variables are there. This is sigma. I'll write those terms now. Sigma n equal to 1 say infinity. This is 2n square plus 3n plus 4 upon 2n factorial. So if it is only constant, it's not a difficult deal to solve, right? If it is only constant, we can simplify it easily. Now see, it's up to you. Either you can take 2n square, 3n and 4 all 3 separately. Like you can start like this. You can write by sigma n equal to 1 to infinity 2n square upon 2n factorial. This will solve it separately. Then this is sigma n equal to 1 to infinity 3n upon 2n factorial. This will be solved separately. And sigma n equal to 1 to infinity 4 by 2n factorial, this we can solve separately. Is that clear? These 3 terms. Okay. So what we need to do? That is fine. Here we have to cancel this numerator n at any cost. The numerator should be only constant, otherwise we will not be able to use the formula. Numerator has to be constant. Similarly here also, numerator has to be constant. This n square we need to cancel it out at any cost. So see, this is very simple. By using the formula, you know that what is n factorial ka formula? N factorial, what is that? N factorial is n into n minus 1 factorial. Correct? This is what we write, n factorial, n into n minus 1 factorial. So in the second term here, there is sigma n equal to 1 to infinity 2n square upon 2n factorial plus sigma n equal to 1 to infinity 3n upon, take 2n outside. So what will remain? 2n minus 1 ka factorial. So n can be cancelled out. So you have 3 by 2 times sigma n equal to 1 to infinity 1 upon 2n minus 1 ka factorial. Now you see, you have got that exact general term which is required. You have now 1 upon odd ka factorial. And we know what is this series is equal to. 1 upon odd ka factorial. What exactly will be this? We have derived this already. When you put n equal to 1, what will get? It will start with 1. So this is 1 factorial. Put n equal to 2. 1, 3 factorial, 5 factorial, 7 factorial. So you have all the odd factorials in denominator. And we already know the series. What is this? This is e minus 1 by e. You see, this is e plus 1 by e. And this is here. From here, if I take 2 common, what is that? This was e minus 1 by e. Right? When I subtracted e and 1 by e, if I subtract that, now this is what I was getting. This will be e minus 1 by e upon 2 is equal to sigma n equal to 1 to infinity 1 upon 2n minus 1 factorial, and that is equal to 1 plus 1 by 3 factorial 1 by 5 factorial up to infinity. Right? So second term also got solved. Okay. Second term also now we know that this particular term is equal to 3 by 2 times e minus 1 by e upon 2. So this is remaining 2n square upon 2n factorial. Similar way, we can simplify this. It is looking lengthy. You see, I am explaining a lot. I am taking a lot of time to explain. That is why the questions are looking lengthy. I am writing every single step which is required. That is what is looking lengthy. Right? So someone who has never attempted such question, I'll recommend that you write it once, you solve it once, then again reattempt it. Okay. So about the first term now, 2n square, 2n factorial. From here also, we have to remove that n square wala term. How to remove that? Similar way, just like we are using the formula, we had to do it twice, that's all. We can do it twice. So this particular term, how to get it? This is n equal to 1 to infinity. This is take 2 out. So n square. Now from denominator, I'll take 2n out, and this will be 2n minus 1 ka factorial. So 1 n got cancelled. You see, now we have sigma n equal to 1 to infinity. We have 1 upon n upon 2n minus 1 ka factorial. But this is still not over. Right? Because we want into these formats. We want everything to be 1 upon factorial, either even or odd or simple factorial. This is what we want. Either this or this, something like this. Right? These two terms we already have made it in the format. This one, same way we are going to convert that by removing the numerator. So what should be next step? You see, what is next step? Next step, what should be next step? This is n upon 2n minus 1 factorial. So let's create 2n minus 1 in the numerator, right? What you have to write this as? This will be equal to sigma. Again, you will divide 2n. So I have divided 2, multiplied 2. Now add 1 and subtract 1. 2n minus 1 and plus 1 divide by 2n minus 1 ka factorial. Okay. Now this will split into 2. So what exactly it will look like? So what we have, sigma n equal to 1 to infinity 1 by 2. So we have, see, 2n minus 1 and then 1. Now separate these two. So we'll have 2n minus 1 upon 2n minus 1 ka factorial and plus 1 upon 2n minus 1 ka factorial. So this sigma we are going to split it into different terms. Is that clear? This 2n minus 1 with denominator, 1 with denominator. Now these two are also going to convert. The second one is already, you see, 1 by 1 factorial, 3 factorial. So this is already your odd wala factorial. This is e minus 1 by e upon 2. This is already done. What about this? The same formula we'll use. So this is sigma. I am only going to simplify this. So sigma n equal to 1 to infinity. This is 2n minus 1 upon 2n minus 1 into 1 lesser 2n minus 2 factorial. Now you can cancel it out. So this is sigma n equal to 1 to infinity 1 upon 2n minus 2 ka factorial. That's it. That's it. We have removed all the variables from numerator. So this, we know what will be the result. If you put n equal to 1, what is it? 0. 1 by 0 factorial. Put n equal to 1. Sorry, put n equal to 2. So 1 by 2 factorial. Put n equal to 3. So 1 by 4 factorial, like that. So this is the even one. This is the even one. 1 upon 2n factorial we had seen, guys. This is the series. You see, 1 by 2, 1 by 4 factorial. This is the series we are talking about, including 1. So what exactly is this? E plus 1 by e by 2. So this we can replace e plus 1 by e by 2. So we have calculated values of all the terms individually, right? All the terms by removing the numerator variable part we have calculated. We have converted every single given term into the general one. This is how it is looking like everywhere, right? So I hope I'm able to explain what exactly we are doing. So now in this question, there are some students who are not like always going to expand in this way. Again, I'm telling you, I'm repeating it. This calculation is looking lengthy because I'm trying to explain every single step. When you solve in the exam, it will be much quicker. These questions will not take more than 3 to 4 minutes. It will take more than 2 minutes, that is for sure, because the calculation, but not more than 4 minutes. So is there any other way by which we can like shorten the calculation? Is there any other way? I just want to know. If you are active in chat, I just want to see that if you are okay. So in chat, like if anyone can tell me that what exactly will be the other way. So I don't think anyone is going to tell. Okay, okay, let me only solve. See, so this is 2n square plus 3n. 2n square plus 3n. 2n square plus 3n, yeah, plus 4. 2n square plus 3n plus 4 upon 2n factorial. So what would be the ideal approach? That instead of solving all three separately, try to generate some terms using this square and the linear one, so that in a single stretch this is cancelled. Now what is the hint for that? How exactly to plan for that? You see this 2n factorial. See, I hope you are understanding what I'm trying to do. What I'm trying to do, you see, you have seen the calculation here. Here, what I have done, I have simplified all three expressions separately, right? I have simplified all three expressions separately, right? This 2n square, it took 2 steps. One from n square to n we went, and then from n to linear constant one. So what I'm trying to do here, I'm trying to club terms in a way so that the square term is getting that is getting solved in a single step. We don't need to do it for 2 times, right? That for that the hint you have to take is from denominator. You just take 2 terms out from 2n factorial. What will it be? So 2n factorial, if you take 2 terms out, this will be 2n into 2n minus 1. Is that clear? 2n, 2n minus 1. So what exactly this is going to be? This is 4n square minus 2n. Now try to generate that particular expression in the numerator. I hope you are getting the point. Why we are trying this? We are trying this so that we can reduce some steps. And this is the type of problem which has been asked at least 3-4 times. This is the type where you have one quadratic expression of n in the numerator. So you must focus here. What exactly the hint we are taking? That from denominator you just write it in this way, 2n minus 1 into 2n minus 2 factorial, right? 2n minus 2 factorial. So 4n square minus 2n, that is what we need in the numerator. Just make it right here. Let's multiply by 2 here. So this will be sigma 4n square plus 6n plus 8 divided by 2n factorial. So this is 1 by 2 sigma 4n square plus 6n. So 4n square minus 2n I need, 4n square minus 2n. So 4n square minus 2n, and then what else? This is minus 2n, right? So I need to add 8n. So 8n and plus 8 divided by 2n factorial. So that's it. You see, 1 by 2 sigma, this is 2n into 2n minus 1 divided by this 2n factorial. So this 2n factorial, if you take out two terms, so 2n minus 1, and this will be 2n minus 2 ka factorial, and plus rest all, you know, that is one step only. So sigma 8n upon 2n factorial plus 8 upon 2n factorial. So these two are very simple, one step. This particular thing was taking 2 steps. Now we have reduced some steps of calculation. Exactly how many steps you see? We have reduced 1, 2, 3. We have reduced 3 steps of calculation. So this is going to save some of your time. So this will directly get cancelled out, and now you know you have all the standard forms here. And you will cancel out by taking 2n outside. So all 3 parts can be solved in a given time. Is that clear? I hope you got the point. I hope you have understood this particular part which I'm trying to tell you. And this is the type of problem which is definitely going to be there in the exam, if it is from exponential series, because this is the type which they are repeating from so many years. And this is just about saving one step. But that also makes a lot of sense, because if you write so many steps, calculation will be complicated, you will lose confidence. Midway, you have already given 5, 6, 7, 10 minutes, and like those 10 minutes will be completely wasted. So some time it will save. So next question, you just give it a try. This one, just try it. Just try this question. I only want you to write numerator such that it gets converted into the standard sigma format within 2 steps, okay, or 1 step only. You see, you have n square 6n plus 10 upon 2n plus 1 factorial. So just give it some time. I'll explain it. We don't need to solve 3 separately. This is what we will avoid, this n square, then 6n, then 10. That will not do. Try to club n square and 6n here. And you know what to be done here, I just explained. So give it a try. I'm giving you some minutes, 30 seconds, 1 minute. Just try to write the numerator. Numerator, I just want you to try out. You have n square plus 6n plus 10. Exact same logic which we used in previous one. Okay. So I hope you have tried by now. So again, we'll not calculate the final answer. In all the problems today, I'm just going to explain you the method, right? So this is 2n plus 1 factorial, right? This is 2n plus 1 factorial. So I can write this as 2n plus 1 into 2n into 2n minus 1 factorial. So this is going to be 4n square plus 2n multiplied by 2n minus 1 ka factorial. Got a point here? So the same term we are going to create there in the sigma, in the numerator part. 2 steps to save some calculation. So here, This will be sigma n equal to, now when you are solving this in exam, obviously you will not write these two steps in your rough work. The numerator directly you have to write the way we are, I'm going to show you here. Got the point, right? You should be this much sharp that you need to do this calculation in your mind. So 4n square plus 2n. So here it is n square. So I'll multiply by 4. So 1 by 4. This is 4n square plus 24n plus 40 divided by 2n plus 1 factorial. Okay? 4n square plus 2n was required. I multiplied by 4 divided by 4. Now I need 4n square plus 2n. Here we have 24n. So 1 by 4 sigma n equal to 1 to infinity. This is 4n square plus 2n upon 2n plus 1 factorial, and plus this will be 40. So this is 2n, this was 24n. So it will be 22n. Right? So let's split it then. Let's split it. This will be sigma n equal to 1 to infinity. Right? I needed only 2n. Here it was 24n. So this 24n I am going to write as 2n plus 22n. Right? And this 22n will be used with this constant. So basically we'll split it. So this is 22n upon 2n plus 1 factorial plus sigma n equal to 1 to infinity 40 upon 2n plus 1 ka factorial. Right? So I hope you can understand the terms now. It's very easy to relate now. The first one, 4n square plus 2n, it will get cancelled out, right? This will be now 1 by 4 sigma n equal to 1 to infinity. This is 2n into 2n plus 1 divided by this. What is this denominator? 2n plus 1. What will remain? 2n plus 1. What will remain? 2n minus 1. 2n minus 1 factorial. Got the point? 2n plus 1, 2n. So this will cancel out. And plus sigma n equal to 1 to infinity. We have 2n, right? So there also we should make 2n plus 1. So to make 2n plus 1, what do we need? 2n plus 1, right? So I need 11, 2n plus 1. So 11 and this was 40. So only 29 I'll keep it for the last one. This is 29 divided by 2n plus 1 factorial. So n equal to 1, you see guys, what will happen here? This will be 11 upon 2n plus 1 will be out, only 2n will remain, 2n factorial, and this is to already in the proper form, n equal to 21 upon 2n plus 1 factorial. You see? So it's like, how many steps? 1, 2, 3, that's all, that's all, that's all. After that, these are only results. You know how to write. This is now 2n minus 1 factorial. You see? What type of denominator you have? Odd factorial. You put n equal to 1 here. 1 factorial. Then this will be 1 factorial. Then this will be 1 by 3 factorial, right? 1 factorial, 1 by 3 factorial. So that is going to be, I hope n is 1 only. So 1 by 4. What is this, guys? 2n minus 1 factorial. N equal to 1, 1 factorial. N equal to 2, 3 factorial. So that's it. This is e minus 1 by e by 2. If you have any confusion, immediately you can switch on, you can switch to this part where it is gone. Yes, immediately. So 1, 1 by 3, 1 by 5, n equal to 1 to infinity. So this is e minus 1 by e by 2. So there we can replace, where is it? Yeah. Where is the question? Yeah, this is the question. Okay. So e minus 1 by 2. Similarly, you see, if you put n equal to 1 here, so it will start with 1 by 2. So there is one term is extra, right? Our series, it started with 1. When it is even series, it started with 1. So we need to remove that 1, right? So this will be 11 times e plus 1 by e by 2 minus 1, and plus this is 29 times. You see, when you put n equal to 1, this starts with 3. So we need to remove one term from here. This is e minus 1 by e by 2 minus 1. Now when you add everything, you'll get your answer. Is that clear? So you see, this is not taking time, right? So if you are able to solve this square wala term properly, if you are not separating this as 3 different terms, it will save your time, right? If you are solving this as a 3 different terms, it will take your time. Always stick to this logic. You see, in JEE mains, whenever they are asking question from this series, they are asking the similar pattern. So please stick to this pattern, and you will be able to find your answer easily. Is that clear? I hope the explanation is clear. So there is one more question. Give it a try. Just give it a try. I am giving you some time to solve. Do we have stopwatch? Yes, we have. Okay. So you have 1 minute. Just try to write the general term. Just split the general terms. Get the sigma, the standard sigma result factorial format. That's all I want. Do it. Okay. So your time is up. So now I'll simplify this, and again, see, there's a similar pattern that you have been doing, right? So there should not be any challenge in solving this. This, you see, this is 2023 wala question. Again, this was a part of integer, but still E is mentioned. So there is not a single time there will be any difficulty to understand ki bhai exponential series has to be used. Okay. So if you split terms here, guys, what you will have? It will be sigma n equal to 0 to infinity. So 2n factorial will cancel out, and you will have n cube upon n factorial. Then again, the second one, if you see, this will be plus sigma n equal to 0 to infinity, and you will have n factorial cancel out, 2n minus 1 upon 2n factorial, because n will cancel out. So here the denominator is now cubic, right? It is cubic. So there some calculation is definitely required. This will not take much time, right? But this particular expression here, you have n cube. So this will require some effort, because the previous logic which we are using, can we use it here? You see, can we use it? We have 2n minus 1, and it's already a product of 2, so we have to split anyway, right? 2n factorial. So I think we need to expand it. Okay. So this, so you know how to solve. Here, similar way, exact same ways we have been doing. Here, first it will be sigma. Just look at these expressions. N equal to 0 to infinity. You know what to do. First, n will be out. It will get cancelled out. So it will be n square, and it will be n minus 1 ka factorial. Okay. So now we'll have n square. Now if we have n square, we can subtract 1, we can add 1. So this will be sigma n equal to 0 to infinity n minus 1 into n plus 1 upon n minus 1 outside. It will become n minus 2 ka factorial, and plus sigma n equal to 0 to infinity 1 upon n minus 1 ka factorial. So this we have converted into proper form. Here n minus 1 will cancel out. So now we have linear, and that can be simplified easily. This is n plus 1 upon n minus 2 ka factorial, and this n plus 1, what exactly we can write? This is n equal to 0 to infinity n plus 1, n plus 1. We can write n minus 2 plus 3. So n minus 2 factorial plus sigma n equal to 0 to infinity 3 upon n minus 2 ka factorial, including this. So now all of them here, n minus 2, if you just take out the term, it will cancel out. it will cancel out n minus 2, n minus 2, n minus 3 factorial. And you see there is a one good thing here. Here you will see one very stupid thing, n minus 2 ka factorial, and plus what exactly is this, guys? This is n equal to 0 to infinity 1 upon n minus 1 factorial. You see, this is simply 1 upon n minus 3 factorial. So if you put 0, 1, 2, it will be negative. There is no point. We'll start with 3. You will start with 3. 3 minus 3, 0 factorial, 1. Then 4, again 1. Then 5, 2 factorial. So this will convert into 1 plus 1 upon 1 factorial, 1 upon 2 factorial. So what is this? This is E. This is E only. Plus, what about this, guys? N minus 2 also will be E. 3E, because n minus 2 negative ones will not make sense. When you put 2, it will become 1. You put 3, same, it will repeat. This is also E. Is that clear? So this part, you know what is the result. So even though it was cubic, it will not take much time to get the result. I hope you are getting the point. I hope the logic is clear. Guys, I hope logic is clear, okay? So I took too much time to explain these 4 questions, but I hope this will not be an element of surprise in your exam. When you come across these questions, you know there is only one way. You just have to get the sigma of that general term wala format, and it's not difficult to achieve that, right? So these questions, if you have in your exam, you are on a positive side. You have to score this. You have to solve this. These all look only complicated, but the simplification, you see, it's very standard ones. Is that clear? So with these 4 questions, like, this was our first topic, and now we'll move to our next part, okay? So next part may what we are going to do. Achha, we had one more question. Okay, this is homework for you guys. This is homework. Let's try it at home. This is homework. Try this. This question came in 2021, and same format, exactly same format. You know what is essay. Everything is same, right? So you can try it at home. We will now move to this next segment, which is PNC. So if I tell you to guess that what topic I'm going to take, what is that one segment where students are always lagging, they have some confusion, they are always like in a state to skip that particular problem exam, what is it? What is it? If you can guess, what is it? Can someone guess in chat? Chat is so active. Okay, chat is very active. Okay, so it is the problems related to Beggars method. Okay, it is questions related to Beggars method. So if you have not heard, someone who is very new to this method, now that is a problem, because you have exam in few days, and if you don't know, it is a problem. Okay, so I'm not going to cover complete, like we are not going to do basic problems from this method, because like I assume that some of you have definitely done. There is a part of this where multinomial is involved, where we have some like problems where we have some restrictions. So those questions will take, right? All the PYQs which we had, right, that will be also taken. Also, there is one segment where division and distribution of objects, that also becomes a challenge to some students. So that part also will cater today. So you see, basically when it is about division and distribution, right, when we talk about division and distribution, in general, there is one group wala method, right? Group formation. And when do we do this? When is this group formation done? When we have a different set of objects, right? When we have different objects, right? When we have different objects and we are going to distribute them in different or identical boxes, whatever it is. But the grouping is involved when we have different set of objects and we want to club them as group them in some strength, right? Then second is when we have identical objects. So when we have identical objects ka distribution, In that case, we go for one method which is called Beggars method, or you see, this is how I'll write it. Like, it's like solving non-negative integral solution, right? And some varieties of it. This is what we can relate to, that when we are going to distribute identical objects in between people or whatever it is, non-negative integral solution method, it should strike, right? Now, there are some other variation also. Identical objects into identical boxes, or different objects into identical boxes. But these two are the core concept. If you know how to do these two, you are done. And grouping is very simple, right? If we have, like, either we have groups with same number of objects, different number of objects, and I hope the formula is clear. Like, suppose if we have like m plus n plus p object, and you want to group them into 3, m, n, p, right? And where these are not identical, m is not equal to n, not equal to p. So how is this grouping done? This will be m plus n plus p ka factorial divided by m factorial n factorial p factorial. Now this part is only what? Group formation. There is no distribution here. This is only division. Now suppose there are 3 people, there are 3 persons, p1, p2, p3, and in between them these many objects were supposed to be distributed. So now we have 3 groups and 3 people, so we can distribute into 3 factorial. But when we are using this formula, this is very clear that the number of objects in the groups are distinct, right? So suppose we have 10 objects, and these 10 objects we are distributing in 3 people, 5, 3, 2. So how it is? 10 factorial, 5 factorial, 3 factorial, 2 factorial multiplied by 3 factorial. Right? I hope you remember this concept. This is one concept. This is grouping. This is distribution of different objects when we have different strength of groups. Now suppose if groups may strength is identical. Suppose if we have 10 and we need to group them into 5, 5. So what exactly we do? We have to remove the repetition, 5 factorial, 5 factorial, whatever repeats, whatever number, 1 by 2 factorial. And if we have to distribute these 2 groups into 2 persons, p1, p2, that will remain same, 2 factorial. So this part is taking care of, this part is taking care of division, and this part is taking care of distribution. Suppose if we had 10 objects and we had to distribute like this, 3, 3, 6, and then 2, 2, like that. So it will be, and suppose in between 4 different people. So 10 factorial by 3 factorial ka square, 2 factorial ka square, whatever is that you divide 1 by 2, 1 by 2, and you are distributing in 4 people, multiply 4 factorial. Is that clear? The repetition ka factorial you have to divide it here. So this works very simple, right? And it will strike very easily. What is the keyword? What is the keyword? When we have different set of objects. Now when we have identical set of objects, we go by non-negative integral solution way. What exactly is that, you see? So this I want to explain because there are certain set of students who tend to miss this, okay? So this particular, I'll explain it, okay? So it's like distribution of, okay? So what we are talking about? We are talking about distribution of n identical objects in R different box. Okay. So basically we have R different boxes and we have to distribute n identical objects. So I'll tell you what is the fundamental here. Suppose we have 3 objects, okay, or let's say 4 objects, and we had to distribute in 2 box, box 1, box 2, okay. So what I'm trying to explain here, I'm trying to derive the result, right? Because this derivation will give you complete idea about Beggars method. You will not skip any question related to this then. So now we have to distribute 4 identical objects, let's say, let's call it P. So we have 4 identical objects, needs to be distributed in 2 boxes. So in how many ways we can do this? In how many ways? In how many ways? So you see, one will have 0, other will have 4, then one will have 1, 3, then 2, 2, then 3, 1, 4, 0, right? That's it. That's it. That's it. How many ways it is? This is 5 ways. So this can be done in 5 ways. Now, to do it in an easier way, how to understand this? Let's say we got one stick, ek danda. So we got one stick. So the left of stick is box 1, left of stick is box 2. So this particular combination is hinting to which one? This particular is 1 and 3. Ye wala, 1 and 3. Clear? If I change position of stick here, so this is P, here and here. So if I change position of stick, let's say I get it here. Now this will be 2, 2. This will represent 2, 2. Understood what is happening? So it's like I am doing arrangement of 4 identical object and 1 stick. So it's like 4 identical object plus 1 stick ka arrangement, and where we have 4 identical object. So this is 5 factorial by 4 factorial, guys. What is this? This is 5. The value is 5, and that is what we have, 5 ways. Got it? So just try to understand how the formula is derived, like how exactly. There is one more way, but this is a kind of easier way to understand. Let's do it for 3 boxes now. The same setup, let's do it for 3 boxes now. Okay? Let's do it for 3 boxes. So we have 4 objects. We have 4 objects, and now we have 3 boxes. So if we have 3 boxes, box 1, box 2, box 3. Acha. Before we go for 3 boxes, in the previous one, like, isn't this setup looking similar to x1 plus x2 equal to 4? This, like, see, whatever solution we have, 0, 4, 1, 3, 2, 2, 3, 1, 4, 0, these 5 are nothing but non-negative integral solution of this equation, where x1 is number of objects in box 1, x2 is number of objects in box 2. So whatever number of solutions we are having, that is nothing but solution of this particular expression. Got it? So distributing 4 identical objects in 2 boxes is equivalent to solving this equation for non-negative integral solution. I hope I am able to make some sense. I am making sense, but I don't know if you have, if you are able to understand or not. You should if you are able to relate or not. Okay. Then next one. You see, now I'll do it for 3 boxes. So I have 3 boxes to fill. I have those 4 objects only. So how exactly is going to look like? You see how distribution will take place. How distribution will take place? You see, it could be 0, 1, 3 or 0, 0, 4, right? Or it could be 0, 4, then it could be 1, 3, then 2, 2, then 3, 1, then 4, 0. So total 5. Then if box 1, we have box 2, we have box 3. So if box 1 has 1, then this will have how many? 3. So 0, 3, 3, 0, 1, 2, 2, 1, 4. If box 1 has 2, so this will have 0, 2, 2, 0, 1, 1, 3. So if box 1 has 3, so this will have 0, 1, 1, 0, that's it, right? 2. And if box 1 has all 4, so this will be 0, 0. What is that? 1 way. So in total 15. Okay? In 15 ways, we can do distribution of these 4 identical objects into 3 boxes. Now just focus here. So what kind of equation I'll have? Let's say x1, x2, x3 is the number of objects into this box. So this is equal to what? 4. Every single solution, you see, distribution of those 4 identical objects in these 3 boxes, different boxes, is equivalent to solving this equation for non-negative integral solution. Okay? Now, what is the result? You see how exactly we get this 15. So this time 3 boxes are required. So we need 3 partitions. For 3 partition, we need 2 sticks. So I got 2 sticks here. 1 stick, 2 stick. Okay? I got 2 sticks here now. So this particular arrangement is 1 to 1. 1 to 1. If I change position of sticks here, you see the P, and then let's say here we have 1 stick, and the second one is also parallel to it. Okay, and then P. So what combination is this? Well, left is box 1, middle is box 2, right is box 3. So this is like 301. 301. Okay. What I'm trying to do here, I'm trying to show you that this solving this equation or distributing 4 into 3, 4 identical into 3 is equivalent to doing arrangement of 4 identical object and 2 identical stick. If you change position of stick, if you interchange, nothing is going to change. This will remain same, right? So sticks identical, objects identical. So how many arrangements are going to be possible? 4 object, 2 sticks, factorial divided by 4 factorial, 2 factorial, and this will be equal to nothing but 15. 6 factorial by 4, 2 will be equal to 15, and that's what we have. So guys, are you able to relate? Now I'm going to generalize this into one final result. That if we are doing, you see, I'm going to generate this as a final result. You see, if we are distributing 15, okay, see, if we are distributing in 3 boxes, we need 2 sticks. If we are distributing in 2 boxes, we need 1 stick. So the number of sticks will be always 1 less than number of box. So now if we are doing it distribution, if we are doing distribution of n identical, in r different box, so how many sticks will be required, guys? How many sticks will be required? R minus 1. So as per the pattern, if I write the result, guys, what will be the result? It will be number of objects plus number of sticks ka overall factorial divide by objects identical, sticks identical. So this translates to n plus r minus 1 c r minus 1. This is the formula. This is the one result which many of you mug up, but I'll strictly recommend you have to understand all the steps, right? So this is the formula. So now if I just explain as this x1 plus x2 plus x3 plus x4 up to xr equal to n. Okay. So what will be the result? Right? So what is this equation? This equation is distribution of n identical objects in r different boxes. Why we have r boxes, n to be distributed. So what is the formula? This is n plus r minus 1 c r minus 1. Got it? Now in this formula, if you observe, there is one limitation. When you write non-negative integral solution, right? When you write non-negative integral solution, you see every single variable is having option of accommodating 0 to n, or not? All of them. All of these boxes have options of accommodating 0 to n. Is that clear? 0 to n. 0 to n. Correct. Now if I have this condition which we'll known as positive integral solution, that all boxes will have at least one. Okay, will have at least one. Matlab, this will be positive integral solution. Why positive integral solution? Because every box is going to have minimum one object in it. So when we have this minimum, whatever minimum requirement is given, you just change the variable. Like how to change? I'll write x1 as t1 plus 1. I'll write x2 as t2 plus 1. I'll write x3 as t3 plus 1. Right? This is my x1, this is my x2, and this is my x3. Likewise, I'll keep on doing till r, tr plus 1. I am replacing variable equal to n. You see, 1 has been added r times, so now I have t1 plus t2 plus t3 up to tr equal to n minus r. Now, for this equation, for this particular equation, if I derive non-negative integral solution, what it will be? This is my n now, n plus r minus 1, so it will be n minus 1c r minus 1. Guys, now can you understand what is x1? t1 plus 1. So when we have found out non-negative integral solution here, that means t1 can start from 0 and go up to n minus r. So even if it is at minimum 0, what is my x1? t1 plus 1, right? So it will have minimum one object with it. Is that clear? So this is for positive integral solution. Now the actual problem is not the setup of minimum thing. You see, in JEE Main we have both kind of questions. Directly based on n plus 1's, n plus r minus 1 c r minus 1 result, and the second one also. Remember this word, guys. Remember this thing. Remember this thing. If you have restriction on minimum, you can always use this result. If you have restriction minimum, you can use the result. If you have restriction maximum, we have to go by multinomial logic. And there, that is the main problem of students. Multinomial logic, not many students are comfortable, they tend to skip it. Only because of one binomial formula, that's it. So I'll mention that result and then we'll start our explanation. So with all these, let's solve some question first. Or should I explain? Or let me complete the theory, guys, first. Let me complete the theory first. So now what I'm trying to tell, that if we have a limitation on maximum part, this will not work. For example, let's say that we have 3 dice and find how many ways the sum is equal to, we are getting as let's say 16, right? Sum is 16, or let's say 12. Okay? So we have 3, so you will write like this, ठीक है भाई, x1 plus x2 plus x3 equal to 12. Okay? Now, the moment you write this, 12 plus 3 minus 1c, 3 minus 1, now this will be wrong. What is the reason? That if you are using non-negative integral solution result, n plus r minus 1 c r minus 1, what it is pointing to, that each outcome has option from 0 to maximum, 0 to maximum, 0 to maximum. Now, which is certainly not right. Right? The dice has maximum 6. It will start with 1, maximum will go till 6, not beyond that. Correct? So this method will not work. Right? This will not work. If you are using n plus r minus 1 c r minus 1, this is not going to work. And I hope I am able to make you understand, because when we write n plus r minus 1 c r minus 1, you see every variable is given option from accommodating 0 to maximum, 0 to maximum n. But here the dice outcome cannot take 12. It cannot take 12, right? So whenever we have restriction on maximum, whenever we have restriction on maximum, there we use multinomial. And this multinomial, guys, you can use anywhere. Multinomial is kind of most fundamental thing which can be used for solving these kind of questions. Multinomial can be used anywhere. Okay? So now there is one more way apart from multinomial, but first we'll see what exactly is this. So throughout this explanation, there is one result which I'll use is this. I hope you have remembered in binomial. Binomial, I personally feel one of the easiest chapter of 11. And if someone is struggling in binomial, matlab, life is very difficult. So the formula which we are going to use is these. Coefficient of x power r in 1 minus x to the power minus n is n plus r minus 1 CR. Okay, n plus r minus 1 CR. Coefficient of x ka power r in 1 minus x to the power minus n is n plus r minus 1 CR. This is one result which we are going to use. In chat, if you can write how many of you are aware of this result at least you have used, you have seen, because we do have questions on them. Okay. So everyone knows. Great, great. Everyone knows. Very great. So what exactly we do, I'll explain here, that when maximum of something is fixed, right? When maximum is fixed, then each variable, like through this question I'll explain, whatever are the outcomes, possible outcomes, or whatever are the desired outcomes, you write them in powers of x. So x1, now what are the possibility? Powers of x, like outcome will be either 1 or 2 or 3 or 4 or 5 or 6, right? The dice will have either 1, 2, 3, 4, 5 or 6. So for every variable, write their options, write their possibilities, write the desired outcomes in powers of x. Same for x2 as well. It will be x power 1, x power 2, x power 3, x power 4, x power 5, x power 6. And same for x3 also. It will be x power 1, x power 2, x power 3, 4, 5 and 6. Okay, so right, all of them have same outcome, right? Now just you see, you need x ka power 12. You are solving for 12. So make any combination, right? You have to pick one from each. So let's say I took x power from first bracket, x power 5 from second one, and then x power 3. So this is giving you x power 12. So this is one way, this is one solution. This is one solution triplet, 4, 5, 3. 4, 5, 3. Right? Now think of any other. So you took x power 6 from first one, x power 6 from second one, and third one also nothing. So this will not be considered. We have to, this is a product where we have to consider exactly one from each bracket. So any other, if you see x power 6, x power 4, x power 2. So that will make you, right, if we multiply, so this will be one way to make product 12, 6, 4, 2. Now can you understand what I'm writing? It's like every time when I'm multiplying them and x power 12 is formed, that generates one solution. It's like in this entire product, I'm trying to find out what is total coefficient. What is total coefficient of x power 12? What is the total coefficient? Like this is one way, so 1 plus 1, 2 ways. Similarly, how many ways, in how many ways I can have x ka power 12, right? So in how many ways? Well, let's see. So it comes to now the PNC part is over, now comes the binomial one. So we have this GP, right? So we want x ka power 12. We want coefficient of x ka power 12 in x square, x cube, x6 whole to the power 3. Okay, in this we want x ka power 12. Okay, so if you want x ka power 12, you see this is GP. So we want coefficient of x ka power 12 in, simplify this GP, a into 1 minus r to the power n and divide by 1 minus r whole to the power 3. So this, you see, we want x ka power 12 in x cube multiplied by 1 minus x ka power 6 into 3 power 3 and 1 minus x power minus 3. Okay. Now can you observe x ka power 3 is to always multiplied. X ka power 3 is to always multiplied. So to get x ka power 12, what is required. We need x ka power 9. We need x ka power 9 in this. We need x ka power 9 in this. In this expansion, we need x ka power 9. Now guys, you see, we have one binomial and with positive power, right? Positive integral power and with negative. So if you are good with binomial, or even if you are average with binomial, even if you are below average with binomial, you must know this, right? So which one will be expanded? The positive one. So we want x ka power 9 in, if we expand this is the first term, 3c0, first term, 3c1 x ka power 6. There is no requirement to write further terms because it will contain x ka power 12. It will not make any combination. Okay. Now in this product, we are looking for x ka power 12. Now I told you this formula we have to remember. In coefficient of, we are looking for x ka power r, the lower index will be r, upper will be n plus r minus 1, right? So see, what all combinations are possible? We want 9. So this 3c0 will require x ka power 9 from here. So it will be 3c0 into, what is x ka power 9? This will be 9 plus 3 minus 1 c9. Whatever is required, that will be lower index, minus. Second term now, 3c1, x ka power 6 is there, right? So we'll need x ka power 3 from here, x ka power 3. So what is the formula? N plus r minus 1 cr. Then that's it. That's it. Only two combinations are possible. So this is 3c0 is 1, 12, 11c9 minus, this is 3c1 is 3, this is 6, 5, 5c3. So 11c9 is 11c2, 11, 10 divided by 2 minus, this 5c3 is 10, 30. So this is 55 minus 30, 25. Right? 3c1 is 3, 6. If there is any calculation mistake, just look into it. But I hope I am clear. I have tried to explain what exactly you have to do. This is what you have to do. You understand the process here. This is it. You have to write every possibility in powers of x. And here it is independent of the other ones, right? Whatever possibility they have, you just mention them over powers of x. It's not like that second variable will be always 1 to 6. By whatever is the given restriction. Suppose if it is said by x1 will start from 3, fine, then I'll not write these two terms, I'll write only these terms. I'll take product of this, this and this, and I'll look for x to the power 12, right? So is the only calculation, which makes things typical, right? So now we'll start with the questions and you will have some better clarity. Okay, so let's have some break. I'll resume in 10 minutes. Okay, I'll resume in 10 minutes. Then we'll start with our problems. Okay, guys. So back from the break. So let's continue now. Okay. So I have explained what exactly, how exactly this works. This Beggars method. This is called Beggars method, by the way. So it's just that whatever possibilities are there for the variable, you will mention them over powers of x. And JEE means they have asked question on this pattern, right? If you feel that we are not supposed to do these kind of calculations, which I have done here in last few steps, you see this is there. And the best part is that questions are always easy, always easy. I have taken all these PYQs here. So let's start with the easy ones, the direct ones. So starting with the first one, you see 2023 question, number triplets where x, y, z are distinct non-negative integers, right? Satisfying x plus y plus z equal to 15. Okay, so we can start with that. So I think let's take some easy ones first in sequence. These three are extra pages. Let's delete them. Okay. So number of ways in which 21 identical apples can be distributed between 3 children is that each child get at least 2 apples. Yeah. So the direct one, let's start with this first. So I think you can frame the equation. You can easily frame the equation. What will be the equation here? 21 identical objects, and how many are there? 3, right? So what type of equation you will make? x1 plus x2 plus x3 equal to 21. There are 3 children, and in between them we are distributing 21. Clear? And what is the restriction? That each child gets at least 2 apples. So for minimum, I already have taught you the way what to do here. What will be done here? We'll replace x1. We'll replace x1 with something. Let's say t1 plus 2, then t2 plus 2, and then this will be t3 plus 2. So this is how we cater the minimum wala part. Whatever minimum is given, we mention this way. So the equation will look like t1 plus t2 plus t3 equal to 15. Fine. So now we'll find out non-negative integral solution. What is that? N plus r minus 1, 18c2. So this will be 18 into 17 divided by 2 factorial. So 17 to 9 is how much? 153. Right? So this 1, is there any calculation mistake which I have done? This is 21. 21 identical apples between 3 gets at least 2, right? So this is, yeah. So T1 plus T2 plus T3 will be 15 plus 6, 21. That is correct. So, sorry. So this is 15 plus 3, 18. So 17C2 will be the answer. So 17 into 16 divided by 2. This is it. So this is 136. That is the answer. Right. So this is JEE Mains 2024 question, guys. You can see the level of question here. This was JEE Mains 2024. You see the level here. So few more questions we'll solve, then we'll get back to the previous one. So yeah. So this was asked in 2021, but this is a pattern which is like which will keep coming back and has the similar logic. So x into y into z is 24. And we are supposed to find out number of positive integral solution, right? So we are supposed to find out the triplets x comma y comma z. So very standard way to solve such problem. What you have to do, whatever number is given, x into y into z, you write that as a proper factor here. 24 is 2q into 3 power 1, right? 8 into 3. So whatever number is there, we'll write into prime factors. So x, y and z. So these variables will be distributed the available powers of 2 and 3. So it will be like x will have something 2 power alpha 1 and 3 ka power beta 1. Y will also have some 2 ka power alpha 2, 3 ka power beta 2. Z will have 2 ka power alpha 3, 3 ka power beta 3. Correct? Because we have only 2 prime available, and those 2 primes will be distributed in all these 3. So now if you see how many 2's we have available, 3. So it's like this alpha 1 plus alpha 2 alpha 3. This is the distribution, right? We have 3 2's and those will be distributed between alpha 1, alpha 2, alpha 3. Then about beta. So in total, how many 3's we have? We have exactly 1, right? So the distribution of alpha and beta, the distribution of 3 2's and 1 3 simultaneously will give us x, y and z. So now if I find non-negative integral solution, it will be 336 5c2 into, what about this? This will be 3 plus 3 1 4 3 3c2. So that gives us 10 into 3 30, right? Now how do we know, how are we so sure that this is giving us the final solution? Guys, you see, just look at the expression here. Think of any one combination. Let's say alpha 1 is 2, alpha 2 is 0, alpha 3 is 1, and here this is 0 1 0, right? Out of 30 ways in which this can be solved, I have taken one such combination. So if I have this combination, what is x? What is the x that looks like? 2 power alpha 1, 2 power 2, and 3 power beta 1. Beta 1 is 0. So x ka value is 4. What about y? Y is 2 power alpha 2. What is alpha 2? 0. And 3 power beta 2. Beta 2 is 1. So this is 3. And what is z? 2 power alpha 3, which is 1, 3 power 0, 2. You see, 4 into 3 into 2 is 24. So we have got one solution triplet, 4 3 2. Guys, I hope this is clear. That this is how, in this way, by calculating non-negative integral solution, we can actually find out the different number of solution. So in total, how many? Total 30. 30 solutions will be there. And this is again JEE Mains question 2021, not 2024, but I am pretty sure this thing will repeat. Now you have one question from 2023, beautiful question, you see, and this came in JEE Advanced also. The similar question came in JEE Advanced, only that they had less number of the digits. So just try it once. Just try to frame the equation. Guys, try to frame the equation. Just try to frame the equation. How exactly the equation will be framed? You see, number of 7-digit positive integers. We have 7-digit x1, x2, x4, x6, x7. So we have one 7-digit positive integer using the digits 1, 2, 3, 4. So not all are being used, such that their sum is 12. So even when you write the final expression, it will automatically strike what exactly should be done. What you will write, guys? This is how you will write that x1 plus x2 plus x3 plus x4 plus x5 plus x6 plus x7. That this is 12. Correct? The sum is 12. Where? What are the options? That each of them has limited option. All of them. The options are very much limited. What are them? The options are either 1, 2, 3, 4. All of them have similar option 1, 2, 3, 4, 1, 2, 3, 4. So you know how to exactly write this, right? We are aware about the limitation of each variable. So how to write this, guys? How to write this? We can write, what can we write? We can write, what can we write? We can write x power 1 x power 2, x power 3. This is what I told you, that the possibility of all the variables, you just mention over power of x. Whatever options, whatever possibilities these variables are having, we'll mention them over power of x. And how many terms are there? In total 7. So the product will be 7. In that, we'll look for coefficient of x ka power 12. We'll find out coefficient of x ka power 12. That's it. If you are able to write this, the topic is yours. You accept it. Like if you don't know that binomial wala calculation, again you will struggle, right? So let's now try to simplify this. So again, this is GP, right? So we want coefficient of x ka power 12 in this. So this is a into 1 minus r to the power 1. First term is x itself upon 1 minus x whole to the power 7. In that, we want x ka power 12. Clear? We want x ka power 12. So we want coefficient of x to the power 12 in, this is x power 7, this is 1 minus x to the power minus 7 and 1 minus x power 4 whole to the power 7. So we want x ka power 12, x power 7 is always multiplied. So from the remaining one, what do we want? We will want x to the power 5. So we can mention this, that we'll want coefficient of x to the power 5 in this 1 minus x to the power minus 7, 1 minus x to the power 4 to the power 7. So as I've told you previously that when you are doing this, you will only explore the negative positive binomial. So we want coefficient of x ka power 5 in 1 minus x ka power 7 into, so if you expand this, what it will be? 7c0 minus 7c1 into x ka power 4 and so on into minus 7. Correct? So x ka power 5. So we have 7c0. This will combine with this and we will require x ka power 5. So kaise aayega? That will be 5 plus 7, 12, 11c5 minus, this is x ka power 4 here. So this x power 4 will require x ka power 1. And again, no need to write further terms, right? There is no point in writing further terms because next one will be 7c2 x ka power 8. Now this is the expression which will give you all positive powers of x. So there is no need. So 7c0, 11c5 minus 7c1 into, this is x ka power 4, we want x ka power 1. So 7 plus 1 minus 1, 7c1. That's it, you calculate it, 11c5 minus 49. Whatever is the calculation. N plus r minus 1 cr, yeah. So 11c5 minus 49. Now calculate it, whatever is, that will be answer. 11c5, so 11, 10, 9, then 8, right? 7. Divide by 5 factorial, 120. So this is 10 into 12, then 4 into 2, 3, 4 into 2, 8, 3, this is 3. So this is 33 into 14 minus 49. So this is 462 minus 49, so that will be 413. Okay. So this is how these topics are done. I hope you are able to understand, whoever is watching, right? So I hope you are able to understand. You see, this is the very recent one. This was in 2023. And there are high chances you will have such questions in 2025, right? So moving on to the next question. Now see, in these questions, we have used some part of this Beggars method, right? Here we had identical object and distribution in different ones, the initial problems. Now, if I talk about this question, we just read it once. What is the question? It says n is the number of ways 5 different employees. 5 different employees. 5 different employees can sit into 4 identical office. So we have employee 1, employee 2, employee 3, employee 4, employee 5. And we have to distribute in identical office, right? So this is a very different kind of question now where you have to figure out, like you cannot just simply write here. Suppose if you feel like this, if we have like 5 object or it's like 4, if you try to have that non-negative wala setup, you will not have it, right? So just think what exactly have to be done. We have 5 different employees to be accommodated in 4 different office. So for identical office. Now, when we are saying that the offices are identical, that will mean, okay, suppose let's talk about one combination. So E1 is here, E2 is here, E3, E4 is here, and E5 is here. Now see, it's like all of the offices are being named 0. So this even if this moves to here, 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 it won't be a new combination. Got it or not? Exactly, understood or not? It's like E1 went to 0, E2 went to 0, E3, E4 went to office O, and E5. So here it's all similar. So the rotation of E1 into E3, E4, if you try to rotate them like this E1 into this office, it will not make any sense because the office is identical. What will make sense here? The groups, guys. The groups. Which person is with which one? What group exactly you are forming? So the formation of group is the key here, right? So see, we have having 4 different office, right? We are having 4 different office. So it's already said, right? Office 1, office 2, identical office. We have 4 different office. Let's give them same name, right? Then what is saying that any number of person including 0. So we can have setups where office is completely empty also. So it's just like these 5 people, how to group them, like how exactly, what all groups will have. So one possibility is that one office is empty, case 1, right? One office is empty, one office will be, 1 will be empty and 3 will be used. 3 are used. Okay? 1 is empty and 3 offices will be used. So now these 5 have to be grouped into 3 different groups, right? These 5 we need to group into 3. So how it will be done? So like 5 people, 3 groups. 5 people, 3 groups. Right? It's like one office will not be used. So the rest 3 will be used. So how those people, how those 5 will be accommodated? It's like 5 ka 3 group you have to frame. So what are the options? It could be 2 to 1 or it could be 3 1 1. 5 people, if I have to group them into 3, this is what I can do, 2 to 1 or 3 1 1. So 2 to 1, this will be 5 factorial, 2 factorial, 2 factorial, 1 factorial, 2 is repeating, so 1 by 2 factorial. Same for this, 5 factorial, 3 factorial, 1 factorial, 1 factorial, it is repeating, 1 is repeating, 1 by 2. So in total, how much will this be? So this is 120 divided by 2 to 2, 8, right? So 15 and plus, this is 120 by 12, 10. So this is 25, right? This was case 1, right? When one office was empty. Now case 2 will take, right? This was case 1. So case 2 will take when case 2 will be taken when 2 office, 2 of them will be empty, 2 empty and 2 used. So it's like now 5 will be grouped. 5 will be grouped into 2 groups. So it will be either 3, 2 or 4, 1. Nothing else, right? It will be either 3, 2 or 4, 1. So what will be the values, guys? It will be 5 factorial, 3 factorial, 2 factorial. So that is 120 divided by 12, 10. And this is 5 factorial divided by 4, 1. So this is 5. So this is again 15. So this is case 2, 2 empty. Now case 3. Case 3, now we'll keep 3 empty. So 3 empty. So it will be only one way. Correct? All 5, 3 offices are empty. So everyone goes to the same office. Right? So one way. So this is 15, 25, 40, 41, and one more case. Case 4, when all are being used. All are used. So those 5 will be grouped into 4. And how exactly? It will be 1, 1, 1, 3. So that will be 5 factorial divided by 3 factorial, 1 factorial ka cube into 1 by 3 factorial. So this will be how much, guys? This will be 5 factorial is 3, 4, 5, 6. So this is became 6. Sorry, this will be 1, 1, 1, 2. 2 factorial. So this is 6 into 2, 12, 10 again. So 25 plus 10, 35, 50, 51. So in total, 51 ways will be there. So generally this happens that when we are solving questions in class, maybe these kind of questions we solve in less quantity, where this counting in groups, we have to do such kind of counting. But I hope you can relate. This is not a difficult one, right? If I categorize, this is very, very simple, right? And only this had to strike that since offices are identical, people will be divided into different set of groups. Clear, guys? Okay. So moving to next one. Now just read the problem, try to solve it. What is the question saying? That number of ways of arrangement of 8 identical books. 8 identical books into 4 identical cells. Books are also identical, cells are also identical. It's like we have 4 shelves. Shelf 1, shelf 2, shelf 3, shelf 4, and we have 8 identical books. Right? Now you can understand how to do the arrangement. There are 4 shelves, all are identical, books are also identical. So just think how this problem can be solved. How are you going to approach this? How are you going to approach this? You have identical books, identical shelf. This X like complete counting. There is groups are also like objects are also identical, right? So the group formation will also not make much logic. Sorry, not using that formula. So just think. And some shelves may remain empty also. It's clearly mentioned. It's clearly mentioned that some shelves may remain empty. Some shelves may remain empty. That also you have to keep in mind. So it's just like, you see, you think of any combination, you have to distribute 8, right? So whatever you write, let's say 0, 0, 0, 8. So this 8 makes one method. So it's like you have multiple ways. It's like you are writing 8 in multiple ways. Combination of 1, right? Combination of 2, right? So for combination of 1, it will be 0, 0, 0, 8, right? So suppose now, if 3 is empty, it will be all in 1. Now if 2 is empty, so what are the possibilities? It could be 1, 7, it could be 2, 6, it could be 3, 5, it could be 4, 4, that's all. And all of them will correspond to 4 methods, exactly 4, right? Because see, all are different, all are alike. So there is no grouping required. Everything is identical. So if I have written it once, if I have mentioned it once, That corresponds to one method. So 3 empty, one way, 2 empty, 4 ways. If only one is empty, then, and we have 8, that is 1, 2, 5, right? What else? Then it could be 1, 2, 5, then 1, 3, 4, right? Or it could be, what else? It could be 1, 1, 6. This is also possible. 1, 1, 6, right? What else? It could be 3, 3, 2. There are many such possibilities. What are others? Could be if I have 2 2s, 2, 2, 4, 4. If I have 3, 2 3s, 2 4s are not possible. 2 1s I have taken, 1 1, 3 3, 2 2. 8 cannot be divided into 3. So any other possibility you can think of. 2 2 4, 3 3, 4, 3 1 we have taken. I think that's all. It will be 5 such cases. 1 2 3 4 5. Right? Now if nothing is empty, then how many cases will be there? If nothing is empty, if we have to write 8 as a combination of 4, right? No shelf is empty. We have taken all the cases. 3 empty, so all 8 into 1. 2 empty, so 1 7 2 6 3 5 4 4 4 cases. So 5 4 9 1 10. So now we have to count those cases where we have 8 and we have 4 cells. So what could be? If I have 3 ones, 1 1 1, 3 and 5, then could be 2 2 2, like that. 3 3 3 is not possible, right? So now if I repeat with 1 1, so 1 1 2. So if I keep 2 alike, right? So if I keep 2 alike, how will it be? So 8 and 2 will be alike. So it will be 1 1 2. Then for 6 we have how many? We have let's start with all different. So if I take all different, 1 2 3 4, that is not possible, right? If I keep all different, that won't be possible. Now minimum 1 has to repeat, so 1 1 got repeated. If I take 1 1 2, then 6 is there, so 6 is like 3 3 4 2, then 1 5. That's it. These are 3 possibilities, right? 2 and 6, 8 3 3 4 2 1 5. Anything else will have 6 as, that's all, right? Then if I have 2 repeating, 2 2 4, so it could be 1 3 and that's it, right? 4. 0 is not possible. 0 we already have counted, right? So if 2 is repeating, so in total you can see 3 2 5 1 6 and there are 10. So I think 16 cases will be there. 3 3 6 if I take, let's see if there is another possibility. 4, right? 4 ke liye we have 2 2 1 3, that's it, right? 2 2 and 1 3. If I have 3 3 here, if I repeat 2 2 4 4, if I repeat 3 3, so 3 3 6 7 8, this is also one way, right? This will be one way. 3 3. Any other repetition? 3 3 6 2 8 4 3 7 1 8. So we have 3 2 5 2 7 10 17. 17 we have counted, so I think there will be one more way, and what exactly will be that? So we have if 1 is repeating, 1 1 2, so 6 will be 3 3 4 2 6 1 5 6. I think that is it. 3. That is also fine. So if I have 1, 1, 2, 1, 1, 2, 4, that is already counted. 2, 4, 6, 2, 8. So I think one more counting is remaining. Totally, in total, you see, I think 17 we have counted. This is 0, 0, 0, 8 when all 3 are empty, right? So one case, then for 8 we'll have 7, 1, 7, 3, 5, 4, 4, 4. Yeah. If we have 3, 1 empty. So 1, 2, 5, 1, 3, 4, 1, 6, 1, 2, 6, 8, 3, 3, 6, 2, 8, 2, 2, 4, 4. What else, guys? So there is one case which looks missing. One case. In total there looks one case missing. What is it? I hope the counting is correct. 3, 5, 8, 4. That is true. Any number of cells will remain empty. So I think any calculation error is there. 5, 4, 9, 1, 10, 10, 2, 12, 12, 3, 15, 18. So which case is there, guys? If 1 is there, 1, 1, 2. If 1 repeats, 2. So 6 is 3, 3, 4, 2, 1, 5. 6, 0 is already taken, right? Yeah. It's 2, 2. 2, 2, 4, 4, 3, 7, 7, 1, 8, 4, 1, 3, 2, 2, 4, 0. 2, 2, 4, 0 is also taken. 6, 6, 7, 8. Okay, so I think some calculation must be there. This will be the answer. Let's check, guys. I think one combination we are losing somewhere. This is 8, 7, 1, 8, 6, 2, 8, 5, 3, 8, 4, 4, 8, 8, 8, 8, 4. Okay, so we can move to next question now. We'll see whatever count is there. Okay. So next, guys, we'll move to, so this is one segment where, like, in the beggars method, where the questions are given, like the questions are very, very easy, but many students are there who like skip it because they are not familiar with these logics, right? So I hope I have helped you to understand this, to understand the beggars method. Okay. Okay. So let's move to the next segment, and that is matrices. So in matrices, you see, there are three majority of the topics which like you will be having. One is the properties related to adjoint, and there are a lot of questions in exam. Then the second topic will be this Cramer's rule, right? I'm talking about determinant and matrices altogether. So from Cramer's rule, you see that if I count PYQs from any particular topic, Cramer's rule will be always the topmost. You have so many questions of Cramer's rule, the probability is too high. So what I assume, everyone does Cramer's rule, everyone is doing properties of adjoint, because they are always there. One more segment is there where you will have problems where higher powers of matrices are mentioned. So we have these three forms, these three formats where questions are always there. But there is one more thing in matrices where the questions are on a easier side, but maybe some student, because the topic is always taught towards the end, they skip it. Right? I hope in chat people are there who can help. Okay. So that topic, guys, is basically this Cayley-Hamilton theorem. If you have heard of, this is Cayley-Hamilton. Right? Basically, I'm talking about characteristic matrix for a given matrix, the characteristic matrix. So for a given matrix, say, let's start with for 2 cross 2. So let's say we have a matrix A, and this is how it looks like, 2 cross 2. So for any 2 cross 2 matrix, the characteristic equation is given by determinant of A minus lambda equal to 0. This is the characteristic equation for any given matrix A. Right? Every characteristic equation satisfies, every matrix satisfies its characteristic equation. So here, if I find out determinant of A minus lambda, it will be A, B, C, D, right? And minus lambda times I. It will be lambda 0, 0 lambda. Determinant equal to 0. So the equation will look like determinant of A minus lambda, B, this is C, and D minus lambda, 0. So if you simplify it, this is A minus lambda, D minus lambda, minus BC equal to 0. So this is AD minus, this is A plus D times lambda plus lambda square minus BC equal to 0. Right? So this is the equation. So this is the characteristic equation. And now what I told you, that every matrix satisfies its characteristic equation. So if you put lambda equal to A here, obviously it will be 0. Lambda is called the eigenvalue. So if you write this equation properly, you will observe something. You just write the equation. The right is quadratic in lambda, the eigenvalue. So lambda square minus A plus D times lambda and plus AD minus BC equal to 0. Now initially what exactly I told, that every matrix satisfies its characteristic equation. So if I put lambda equal to A, obviously it will satisfy, right? If I put lambda equal to A here, it will be 0, it will satisfy. So now here in the equation, if I replace lambda with A, so this is A square minus A plus D into A and plus AD minus BC into identity matrix will be 0. Right? Now carefully if you observe, this is A square minus trace of matrix A, and this is determinant of A, right? What is determinant here? This is AD minus BC. This is determinant of A into I equal to 0. And this is what, guys, you have to remember it. Because in exams, what is going to happen? You will be given characteristic equation. They'll provide you characteristic equation, and from there, these information you have to use. Now, if you are not aware of this theorem, if you're not using this, you will start to multiply, you will take square, you will take cube, right? Because see, we derived this for 2 cross 2 matrix. We derived this for 2 cross 2 matrix. So when we are deriving this for 2 cross 2 matrix, what exactly happened? We got a quadratic. And the coefficient of A and the constants are kind of fixed. Like if you do it for 3 cross 3, if you have any matrix which is for 3 cross 3, if A is a matrix which is 3 cross 3. So this is how the characteristic equation will look like. It will be something A cube minus trace of A into A square plus some constant into A square, A, and minus determinant of A into I equal to 0. So this is how the matrix characteristic equation for 3 cross 3 will look like. So the constant, which is the basically coefficient of identity matrix, and the coefficient of A square, that we have to always take hint from. So the coefficient of one power lesser will be trace, and the coefficient of identity matrix will be what? It will be determinant, right? So in exams, they give question directly in this format, and you have to just guess what is determinant, what is trace, or you have to somehow use it, right? No need to do this squaring, because this method is used for calculating inverse also. Using this, you can, suppose if you have characteristic method, suppose if you have characteristic equation for some matrix, let's do it on next slide. Okay, so suppose if we have any characteristic matrix, like something A square plus, suppose A into A plus B into I equal to 0. So to find out inverse, this equation can be used. We'll multiply by A inverse. So it will be A plus A into I and plus B into A inverse equal to null matrix. So you can see from here, we can find out A inverse will be minus A into I, and it will be divided by what? 1 by B minus. So this Cayley-Hamilton will be used to find out inverse as well. So be very proactive in understanding the coefficients and everything here, right? So for 2 cross 2, you will see a quadratic. Coefficient of A is negative of trace A, and determinant of A is the coefficient of identity matrix. For 3 cross 3, the similar pattern, the constant is negative determinant, and here it is negative of trace. Okay, so I hope it is clear, guys, right? So now how exactly this is being used in exam, what kind of questions they ask, how it is time savior for us, let me show you. Just look at this question here. This question is from 2024. What is being said? There's a matrix given, it's given A cube. Okay, you have A cube. So A cube minus 4A square plus A and plus 21I is 0 is null matrix. You see, this information is given, guys. Okay, this information is given, A cube minus 4A square plus A. So if you compare, so trace of A is known, right? What is trace of A? So trace of A is 4, right? And if you compare with a standard one, the coefficient of identity, that is minus of determinant of A. So if I compare here, minus, so determinant of A will be minus 21. So these two information we have. Now this is not a difficult task to find out A and B, right? What exactly we are finding out? A and B itself, you see. Now you have two equations, two variable. What is trace here? Trace is 4, and that is equal to 2 plus 3 plus B. 2 plus 3 plus B. So from here we got B very easily. What is B? 3 to 5. B is minus 1, guys. Right? B is minus 1. So B very easily we have got minus 1. So if you got B ka value, next also we can find out. Determinant is minus 21. So this is 2 into, this is 3B minus 5. Right? I'm not good with calculation. So again, if I do some mistake, please excuse. So 2 into, this is 3B minus 5 minus A into, this is B minus A into, this is B, and then again this is 0. And this determinant, guys, is equal to minus 21. This is minus 21. So B is minus 1. So 2 into minus 3 minus 5, this is minus 8, and plus A is minus 21. So value of A will be minus 5. Correct? This is minus 16 plus there, it will be minus 5. So A is minus 5, B is minus 1. So what is asked? 2A plus 3B. So minus 10, minus 3. So answer should be minus 13. You see the amount of time we have taken. Like if I'm solving this question in exam, how easy it should be. So I don't know, like if someone is there who is not aware of this characteristic equation, because this is a standard part of curriculum, right? So if you are someone who has not done, recently when I was discussing with one of the students, I came to know that he has no idea what characteristic equation is. So guys, you see in matrix, they ask this a lot. Some shift, definitely you will have problem with Cayley-Hamilton theorem. And if you know the logic, you will take seconds to solve. Okay, so let's try next one. So this is also JEE Main 2024. You see the question here. Let A be a 2 cross 2 real matrix and I be the matrix of order 2. Roots of equation be 1 and 3. Right? Roots are 1 and 3. So if I have to write characteristic equation, guys, I know how to write. That will be A square minus sum of roots 1 plus 3, 4A and plus product of roots. So 3i equal to 0. So I know that for this matrix, trace is 4, determinant is 3, right? So then sum of the diagonal elements of the matrix A square is. So they're asking what is sum of elements of, okay. So now this A square minus 4A plus 3i, right? So we have to calculate what is A square is. Suppose A is A, B, C, D. Fine. So what information do we have? We have A plus D equal to 4 and we have determinant AD minus BC is equal to how much? It will be 3. Correct? We have A plus D equal to 4 and we have AD minus BC equal to 3. And what exactly is being asked? Sum of the diagonal elements of matrix A square is. Okay. So what will be A square, guys? What will be A square? A square will be how much, guys? A square will be A, B, C, D multiplied by A, B, C, D. Correct? A. So if you multiply here, it will be AB into A. It is A square plus BC. And this is, so we need only diagonal elements, right? So this is A square plus BC, and what will be this element? It will be CD into AC, CD into BD. It will be BC plus D square, right? So we need A square plus D square plus 2BC. Okay? We need A square plus D square plus 2BC. This is what is being asked. Now can you take hint? We are having A plus D, 2BC, that is that we are having. So if I do one thing here, this is what I have to calculate. So A square plus D square. Now if I have, if I add 2AD here, and if I subtract 2AD, I think my job will be done. You see, question is over. And I am dependent on only these two information. I have AD minus BC equal to 3 and A plus D equal to 4. So if I add 2AD, I think my job is done. This will be A plus D ka square and this will be minus twice of AD minus BC. And both these information are known to you. What are the information given? A plus D, this is 16 and this is 3. So this is 6. So the value will be 10. This thing. You see, how simple this question is. And in fact, when I was discussing paper of 2024, most of the questions in matrix, which was related to this Cayley-Hamilton theorem, this much easier it was for almost all the questions, right? There's a simple information. If you don't know, it will take a lot of time to solve. Here you cannot do this, that you will take A and then you will put it in the characteristic equation, that we don't have to do. Remember the result. Okay. Give it a try. In fact, slightly easier. Just try this question. This is even easier. This question is even easier than the previous one. You just look at the question here. I see chat box here. Chat box is completely empty. Okay, everyone is busy. Okay. Achha, some comment is there about achha, one case was repeated. Okay. Fine. Okay, so let's solve this question. A is 1 lambda 510. A inverse is given, right? So it's even easier. This was asked in 2023. This question is even easier, guys. What we have to do here? What exactly we have to do here? So A is 1 lambda 510. A inverse is A alpha A bi. Okay. So this A inverse is given alpha times A and plus beta times I. So let's form the exact this exact characteristic form here, equation here. So let's multiply everything by matrix A. So A inverse will be I, right, equal to alpha A square plus beta into A, right? So this is how the equation will look like. Alpha A square plus beta A minus I equal to 0. We have to keep coefficient of A square 1. So A square plus beta by alpha times A minus 1 by alpha times I equal to 0. So now we can easily relate, right? So this is A square minus beta by alpha times matrix A and minus 1 by alpha times I equal to 0, correct? So alpha plus beta is also known. Now if I write characteristic equation for this matrix, so it will be A square minus, what is trace? 11, right? Trace is 10 plus 11 and plus determinant 11 minus 10 minus 5 lambda. 10 minus 5 lambda into I equal to 0. Now just compare. You see how simple is this? Alpha plus beta is already known, minus 2. So we have beta by alpha, right? If I compare these two, so I know that beta by alpha is 11. So from here, you see beta is 11 alpha. And from problem, it is known that alpha plus beta is minus 2. Alpha plus beta is minus 2. So beta is 11 alpha. So 12 alpha is minus 2. So alpha value is minus 1 by 6. So if alpha is minus 1 by 6, you have beta also. What is beta, guys? Beta will be minus 11 by 6. Okay? Minus 11 by 6. So beta alpha, both are known now. What is missing? Lambda. Now to calculate lambda, you see determinant value by 10 minus 5 lambda is equal to minus 1 by alpha. Alpha we know minus 1 by 6. So 10 minus 5 lambda is alpha is minus 1 by 6, so plus 6. So 5 lambda is 4. So lambda is 4 by 5. So we have all the information now. We got lambda, we got beta, we got alpha. Everything is there. We can calculate. You just see the calculation. It's just seconds. It will take seconds. Next one. Similar question, right? Almost similar question. Determinant of A, like here to we don't even have to write anything, right? Determinant A is asked, already it is in proper format. So determinant of A will be equal to what? This is always plus of 18, so B will be answer. Right? A square plus gamma A plus of determinant of A into Y is the Cramer's rule. You see, seconds. It will take 1 second to tick mark if you are aware of this further. So there were many other questions as well from this segment. So we'll take a 5-minute break and then we'll start with the next segment. Trigonometric inequality basically. I'll be explaining these some inequality concepts for trigonometry. So just stay for few minutes. 5 minutes, I'll be back. Okay. So so in trigono inequality, there is like one very simple funda which we have to keep in mind. There are many students who sometimes like, they skip simple inequality problems also in JEE main. So I'll give you a very simple logic that for sine and cos, if you are dealing with sine or if it is function of cos, right? Or let me write the standard format. So if it is, let's say, some sine of any angle greater than k, sine theta less than equal to k, or for cos theta greater than equal to k less than k. So if you are having sine cos inequality, right? So you will solve for 2 pi length and then you will generalize, and then you will generalize solution by adding 2n pi to each end. Okay, we solve for the periodic length. Like if we are doing for tan, the same thing if you are doing for tan, like tan theta greater than equal to k, tan theta less than equal to k. So if you are dealing with tan, what you have to do, you have to solve for length pi, right? And then generalize. To generalize, add n pi to each end. So why 2n pi and n pi? The reason is the tan function will be periodic with pi and sine cos will be periodic with 2 pi, right? So suppose for example, like if for sine, if you have something like sine theta greater than 1 by 2, right? So if you have suppose sine theta greater than 1 by 2, so suppose this is a line for 1 by 2. So if it is greater than 1 by 2, this part will take, and this part obviously will repeat after 2 pi length again. So if this was some angle theta 1, this will be 2 pi plus theta 1. So next it will be 4 pi plus theta 1, then 6 pi plus theta 1, right? So we'll add 2n pi to each end of the interval. So for example, I'll just show you one. Suppose we have to simplify this. Suppose we have to simplify that sine 3 theta plus pi by 3 is greater than equal to half, right? Suppose we have to find a general solution. We have to find general solution for such kind of inequality. So whatever is given, you start with pi only. You take that whole thing as one angle. That I don't know what to solve for this. Initially, I'll solve for only sine phi greater than half. I'll solve for this first. So draw the graph, write the interval. So sine phi greater than half, right? So 2 pi. So this is the interval, this is the line 1 by 2 wala line 1 by 2, right? So I'll solve for phi first, then I'll find for theta. So sine phi should be greater than half. So this is the part we are supposed to take, right? So we will write for what angle sine. What is the angle of intersection here? What are these angle of intersection? So angle of intersections are sine. When is sine 1 by 2? At 30 degree, and then in second quadrant pi minus 30, which is 150 degree. So 5 pi by 6, right? So we need all those angles which are from pi by 6 to 5 pi by 6, right? This is what we need. What will be our general solution? I'll write, first we'll write for 2 pi length. What is the length I considered? I considered 2 pi length as interval 0 to 2 pi. Remember, length is fixed, not the interval. If you want, you can take from minus pi to pi also. You can take from 2 pi to 4 pi also, right? It's not the length, it's not the interval. Length is fixed, and we try to take that length which gives us continuous solution. So suppose this is the solution I got. So I can easily write that phi here, the sine phi greater than half. I need phi angle from which angle to which angle? pi by 6 to pi by 6. For any angle in this interval, sine will remain greater than half. So this is my solution. Now generalize the solution here. So general solution will be, since I am dealing with sine, so sine general, sine I'll add 2n pi to each end. So 2n pi plus pi by 6, 2n pi plus pi by 6. Okay. So I've generalized the solution. So after generalizing solution, what will be done? Now you replace this phi with the original angle. So original angle is 3 theta. So phi belongs to this. So 3 theta plus pi by 3 will belong to 2n pi plus pi by 6, comma 2n pi plus 5 pi by 6. So now you have to subtract pi by 3. So 3 theta will belong to 2n pi plus, so pi by 6 minus pi by 3, what will it be? Pi by 6 minus pi by 3, it will be minus pi by 6, comma 2n pi, and plus 5 pi by 6 minus pi by 3, it will be pi by 150 minus 60, it will be 90. So this is my solution. This is my final solution, 2n pi, no, not final, this is 3 theta. So what will be for theta, guys? For theta will belong to 2n pi by 3 minus pi by 18, comma 2n pi by 3 plus pi by 6. This is my final solution. Right? In the exam, what happens? You have to substitute different values of n. You put n equal to 1, 2, 3, 4, minus 1, whatever. When you put values of n, you will see what intervals are in the options and you can take it. Like leaving trigonometric inequality will be a very, very bad decision, right? Because this is the process. That's it. That's it. Whatever is given, you solve for simplest. One thing, one more thing I told you, that the length is fixed, interval is not, and the interval should be taken such that we get continuous solution. Like here, I could have taken some other interval as well. Suppose if I take from here, from pi by 2. If I take from pi by 2 to 5 pi by 2, the interval is still 2 pi, but I'll get solution in discrete manner. Now again, that is not wrong. It will give you correct answer at the end, but later on what will happen? The solution will look complicated, that's all. That's it. But when you put values of n, ultimate all the intervals will be similar. So one more example I'll just give you. Suppose if it was cos. Suppose if we had to solve that some cos pi is greater than half, right? So if you plot graph of cos, right? So now cos is greater than half. So this is half line, right? Now here, instead of going with 0 to 2 pi, because in 0 to pi you can clearly see that we are getting one discrete solution, right? This segment, then union of this segment. So instead of that, why don't we go from minus pi to pi? You see, here if I, that's it. So this is minus pi, right? So if I go from minus pi to pi, right? If I go from minus pi to pi, still the length is 2 pi and the required solution is greater than half. So this part will be, the continuous part will be answered. So here I have taken, what is the principal interval? I taken as minus pi to pi. And the reason is that if I take 0 to 2 pi, it will be in discrete way. So I have taken in a continuous way so that I can take it from minus pi to pi. Okay. So now this is the solution. Now what are the angles? At what angle cos is half? So 1 by 2 will be at 60 degree. So it is pi by 3 and it is minus pi by 3. Okay. Minus pi by 3 and pi by 3. So you will write solution as phi. Your phi will belong to, pi will belong to, first you will write minus pi by 3, say pi by 3, and then you will generalize it. So what will be general solution? Pi will be from 2n pi minus pi by 3, say 2n pi plus pi by 3. That's it. Since equality is there, so that is why brackets are included. So you see this is how you are going to attempt any inequality. That's all, nothing else, nothing else. For it is, if it is tan, you will do it in the interval of pi. So we have one PYQ here. all possible values of theta for which sine 2 theta plus tan 2 theta is positive. So if you try here, if you try, it looks the options are just trying to intimidate you. That's all. If you know the logic, it will not take much to solve. Let's try it. Sine 2 theta, tan 2 theta. So this is sine 2 theta plus tan 2 theta greater than 0. So this tan here you can write sine 2 theta plus sine 2 theta upon cos 2 theta greater than 0. Okay. Now what will be our next step? Next step will be I'll take sine 2 theta common. So I'll get 1 plus cos 2 theta upon cos 2 theta greater than 0. So I am getting tan 2 theta into 1 plus cos 2 theta greater than 0. Now guys, what is 1 plus cos 2 theta? Everyone knows it is a square term. So tan 2 theta into 1 plus cos 2 theta is 2 cos square theta. Now we only have to make sure, we only have to solve this part, that tan 2 theta is greater than 0. We only have to solve this part. Okay, we only have to solve tan 2 theta is greater than 0, right? We only have to we only have to check this 2 cos square theta here, the theta, this 2 cos square theta here, this should not be equal to 90. So whatever interval we take, this cannot be 0. That is the only thing we have to keep in mind. Now this tan 2 theta greater than 0, if you simplify this, guys, what will happen? You see, now it's just the standard inequality question, and since we are dealing with tan, so I'll not look at 2 theta, I'll look at this is simply tan phi greater than 0, and graph is must here. So take any interval of length pi. So I'll take from minus 90 say 90. So between minus 9 to 90, this is how tan looks like, right? So for positive matlab 0 say pi by 2. So phi will belong to 0 say pi by 2. Correct? 0 to pi by 2, tan is positive. So phi is what? Now I'll generalize. So phi will belong to n pi plus pi by 2. So now replace phi with the original angle, which was 2 theta. So 2 theta will belong to n pi say n pi plus pi by 2. So theta will belong to n pi by 2. So n pi by 2 to pi by 4. Right? That's it. Your job is done now. So we have got the interval. Now if you start substitution of integral values of n. So if you put n equal to 0, theta will belong to where to where? You see, 0 to pi by 4. If you put n equal to 1, then theta will belong to, this will be pi by 2, and this will be pi by 2 plus pi by 4, 3 pi by 4. If you put n equal to 2, this theta will belong to pi 2, pi plus pi by 4, 5 pi by 4. So union of all these intervals will be your answer. So if you see pi by 4, pi by 2, 3 pi by 4, pi to 5 by 4. Now if we put n equal to 3, that is what I'll get. So theta will belong to where to where? 3 pi by 2 to 7 pi by 4. So very clearly this is our answer, option D. This is option D will be our answer. I told you initially that the options are only trying to intimidate you, and here you can see the solutions is so simple. What you have to keep in mind, that this should not be equal to 0. So just cross check in the interval, do we have any odd multiple of pi by 2 in these intervals? Do we have? No, right? This is 1822, no, here also not, here also it is excluded. So we don't have a single angle here which is making this is 0, so everything is fine. That is your solution. Previous to this problem, there were some inequalities given, and again all these inequalities have very standard approach. What you have to do, simplify it, write solution in this standard interval, add n pi to n pi depending on sine, cos, tan, and then you will have it. At the end, you have to do this part. You have to put values of n just to see the intervals, because this will rarely happen that general solution will be provided, because already you know general solution someone can solve with sine, cos, or tan, so it is confusing. Fine. So now we'll move to the next part, which is slightly ignored these days by some students, the properties of triangle, right? Looks like that it is out of syllabus or whatever it is. But see, there are some basic information which you must know. There are some topics which everyone must know, because the questions have been coming every year. One not, if not one to the another format. Every year there are problems, right? So you cannot simply ignore everything. Properties of triangle, it is a huge chapter. We are not supposed to know everything, but this simple, like basic things which are there in straight lines also. In straight line chapter, we have some similar properties, similar formulas, or similar concepts also mentioned. So we have to know certain results. You will never know when you are going to have that question in your exam paper. Heights and distance also you have to like solve it. So properties of triangle, some results I'll mention, which are you have to, at any cost you have to know, otherwise there will be a great amount of struggle. Right? It should not be as a surprise that what kind of question is this. So in properties of triangle, you know, that when a triangle is mentioned in a standard way for a triangle, so suppose this is vertex A, this is B, C. So opposite to vertex A will have side length A, and small letter will represent side length. So this is side length B, and this is side length C, right? So there are some results many of you have must done in physics as well. So I'm talking about only those results. You have to remember it. You cannot ignore it. If you ignore, you are going to lose on some solutions, right? And there are hardly 6-7 formulas that we should know, and we have been using that. So all the things that we did in straight line, somehow it is related to that, and I'll mention all those results, okay? And I'll show you some PYQs also. So just once I'll look at the chat. Okay, ठीक है, देखिए. So we have triangle ABC. So there are some standard results which we must know. One is sine rule. I hope you are aware. I'm not going to derive it. Unnecessary, will waste our time. So sine rule, it is A by sine A, B by sine B, and it is equal to C by sine C. And this is always equal to 2R, where what is R? R is circumradius. This R is circumradius of the triangle which will circumscribe it. So I'll plot that also. You see, for a triangle, there will exist a unique circumcircle which will pass through all its vertices. Okay, there will exist one unique circumcircle. The center is called circumcenter, and distance of center from the vertex is circumradius. So by the property, I think you are aware, if this is angle A, so this is also angle A. Correct? So now this is not something which you have never seen. You are supposed to remember these results. So one is sine rule, A by sine A, B by sine B is equal to C by sine C. Then cosine rule. The second rule, and most of the question that you are going to see is on this cosine rule. Most of the question, right? The previous 3-4 years, like if I count frequency, you will have more questions on cosine rule, and which you already have been using. So I assume that you remember the result. The cosine rule is that for this triangle, cos of A is B square plus C square minus A square divided by 2BC. Where cos of B is equal to a square plus c square minus b square divided by 2ac. If you are writing cosine of c, so that will be a square plus b square minus c square divided by 2ab, right? This is cosine rule. Most of the questions, guys, we are having from cosine rule only, the PYQs if you see. Then we have this projection rule. Now, what is this projection rule? In that you see the side length A, and all these results can be derived very easily. Just draw perpendicular, you will see. So side length A is B cos C plus C cos B. Side length B is A cos C plus C cos A. Side length C is A cos B plus B cos A. Right, and I can show you that it's very simple to derive. So what we do, we draw right angle here. So if this is, see, if this is angle B, right? So it is dividing into two parts, BD and DC. So what is BD? BD is projection of C on this. So BD part will be C cos B. This will be C cos B, and this part will be projection of this side onto this. It will be B cos C. So when we add, what do we get? We get this entire length A, right? So all these results we can derive within seconds, right? This is the simple geometry, but we definitely should know these results. Then after that, the other result which we should be aware is the half angle formula. Or I hope you are aware what is S stands for. The semi-perimeter. S is A plus B plus C by 2. For the triangle, S stands for semi-perimeter, A plus B plus C by 2. And the area delta is given as S into this, so you have studied 9th, S minus A, S minus B, S minus C, right? This is formula for area of triangle. Delta stands for area of triangle. So one more area formula, delta, is half AB sine C, like sides and then angle between. Like if I use AC, it will be sine B. If I use AB, it will be AC, BC. If I use BC, it will be sine A. So this also again we use in our straight line, circle, other chapters as well, right? So this is basic geometry. Not like that if SOT is not mentioned, they cannot ask question from these results. These are very basic results. You are supposed to know these results, right? They can ask question from these. Again, if someone asks that how, sir, it is AB sine C, these derivations are very, very simple. So first one I'll show you, AB sine C. You see, so AB, now if I draw perpendicular here, right? If I draw perpendicular from vertex C, so what will be length of C? What will be length of C from here? You see, if I draw perpendicular, right, from C, so what will be length of this perpendicular? It will be how much? We can write this terms of in terms of B or in terms of A, right? So this is, suppose this is angle B. So sine B, what will be sine B? Sine B, you can write sine B, like this is a right angle triangle here for you. Sine B will be this length L upon hypotenuse A. So L is A sine B, right? L is A sine B. So area of triangle is what? Half of perpendicular into base. So what is base? Base is C. So half A sine B into C. So it is AC half sine B. So it's like the side and the angle between the sides, that is taken. Got it? So this is not something new for you. So these formula we can have questions on them. Okay. Good. Then moving to the next segment in this formula, like there are few more which we must know. So we got semi-perimeter, we got Heron's formula for area, right? We got area of triangle. Now we can relate area of triangle with circumradius also. Can you see? We can relate area of triangle. You see, what is R here? What is R? Circumradius R. This is also result here. So this is A, right? This is circumcenter. So from circumcenter, if I draw perpendicular, it will bisect also. Now this is A. So what is cosine of A? Cosine of A, what is this length? This is A by 2. So base sine of A, sorry, sine of A. So sine A will be what? Sine A will be perpendicular upon this, so it will be A upon 2R. So that we already have written here. So here we have R equal to, it will be this perpendicular, this is sine A equal to, this will be perpendicular upon hypotenuse. So it will be A by 2R. So this is 2R is equal to A by sine A, that we already have seen from here, right? So we can relate this circumradius with all the sides. How? So this R is here A upon 2 sine A, right? A upon 2 sine A. Now what is sine A? I can write sine A from here. I can write sine A from here. Sine A will be 2 delta upon BC. It is equal to A upon 2. Sine A is 2 delta upon BC. So you see how symmetric formula it has come. So radius, circumradius is equal to ABC divided by 4 delta. ABC divided by 4 delta, where delta is area of the triangle. So this is again a formula which we keep on using. So you must know this result as well. So we have sine rule, we have cosine rule, we have projection rule, then area of triangle, then circumradius of the triangle. This R is circumradius of the triangle. So till now, like if there are 40 questions, if there are 30 questions, 90% questions will revolve around them, right? Some questions, there are some problems where in radius is also mentioned, and in radius is something you have seen in straight line also. So it's not like that you are not completely aware about what exactly this term is. So in radius also, let's write what is in radius. In radius. So in radius is like for a triangle, for a given triangle, this is circle which is touching all the sides, and in radius is the radius of that circle. I hope it is clear, right? And the center is called in center. The center will be in center, and this is in radius R. Now to find out R, there are multiple results, right? There are multiple results by which we can find out R. So some might ask that, sir, why not half angle rule? Now half angle rule has not been that useful, but if you want, I can write it. What I'll recommend, that if we stick to these results, that will be sufficient, right? Half angle rule also, like sine A by 2, cos A by 2. It's not something which we cannot remember, but still we have seen less number of questions, so we'll be slightly precise. There has been questions from in radius, so that we'll use, and especially the relation between in radius and x radius. Sorry, in radius and circumradius. So this R here, like you can derive easily, guys. You know that if you join here, this will be the half angle. This is A, B, C. So this is in center. So the line joining from vertex will divide into a half angle. So this is B. So this will be B by 2 angle. If I join this, this will be C by 2 angle. So suppose this is point D. So this length A will be what? Length A will be BD plus DC. So if you complete this calculation, you will be able to derive one fine result which is being used a lot. I want to derive this result because this keeps coming. So let's do it. So length A is BD plus DC. See, it's not like that this is only formula. There is one more, the simplest one. Let me start with the simplest one. So what is area of this triangle? Can I write that delta will be equal to half? Delta will be equal to half of. You see, for the triangles, you just focus on the triangles which I am plotting. So here, so this is one triangle you can see. So for this triangle, this is working as a perpendicular. This is side C. So C into R, correct? C into length R will be area. for that. And we have such 3 triangles. So half of R into it will be A plus B plus C, right? One will be R into C, then R into B, then R into A. So we have 3 triangles. If you add, this is what you will get. So what is R here, guys? A plus B plus C is 2S. So R is delta upon S. This is the first result for in radius, and you are supposed to remember this, right? Well, delta is area of triangle and S is semi-perimeter, right? So this is not something difficult. We have derived within seconds. Then second result, which is the most famous. There are most famous. So that I'm going to derive. So what I told you, that R here is nothing but BD plus DC. How is R BD plus DC? Because this is in center, and obviously in center is point of intersection of what? Angle bisectors. So we have this B, angle B by 2 here. So what will be length BD here? What will be length BD? Can someone tell? This length A is BD plus DC. So BD in terms of R, what I can write? Like, what will be tan B by 2 here? Tan B by 2 will be equal to, is in this triangle. In this triangle, I can see this tan B by 2. So tan B by 2 will be perpendicular R upon BD. So BD is R cot B by 2. So this is R cot B by 2, and DC will be similarly R cot C by 2. Got it? R cot B by 2, R cot C by 2. So let's continue this calculation. So let's write everything in terms of cos and sine. So R will be, this is cos B by 2 upon sine B by 2, and plus this is cos C by 2 upon sine C by 2. Okay. So now if you cross multiply, so A will be R multiplied by, this is cos B by 2 sine C by 2, and plus cos C by 2 sine B by 2, and divide by, we have sine B by 2 sine C by 2, right? So now if you write further, if you multiply, so A into sine B by 2 sine C by 2 is equal to R multiplied by, now you see sine A cos B sine B cos A, so it is formula of sine B by 2 plus C by 2. So it is sine B plus C by 2. Now A ko I can write 2R sine A. This A I have written as 2R sine A into sine B by 2 sine C by 2 is equal to R times sine. This B plus C will be pi minus A. So pi by 2 minus A by 2. So 2R. This sine A also we can expand. It will be 2 sine A by 2 cos A by 2. And then we have sine B by 2 sine C by 2 is equal to R times sine 90 minus theta is cos theta. So cos we can cancel out, and this is the result I was talking about. Very, very useful result, that R will be equal to 4R is equal to 4R sine A by 2 sine B by 2 sine C by 2. Like, there has been multiple questions last year itself where we have seen this expression, right? So I strongly recommend that do remember this result. The reason for derivation is only to show that this is not something difficult, right? So this result you have to remember. For in radius, we will have very simple question based on these two, right? So in general, these are the results on which you might have problems, right? And when you read problems, you can relate, right? You don't have 10 formulas here. You have area of the triangle, semi-perimeter, then you have this in radius and circumradius all together. Then you have this area of triangle and relation between circumradius and sides and area of triangle. So all these results are something which are very easy to memorize. even if you are doing this for the first time, if you have not been taught, these 4 or 5 informations are sufficient for JEE mains purpose, right? So I'll show you some PYQs. Okay. Let's solve some PYQs here. Okay. Some 2 extra pages not required. Okay. So look at this expression. This problem came in 2024. If someone is there who is saying that, sir, this is out of syllabus, it is not. One way, these basic results are not even something which we should be bothered about. These are something which we have to remember. Okay, so you can read the problem and try to simplify it. So in a triangle ABC, BC side is 7, AC is 8, AB is alpha. Let's draw this. If we draw this, what is given in this triangle? Suppose this is triangle ABC. This is triangle ABC. So side BC is 7, matlab A. A is given 7. Side AC is 8. So this is opposite to B. So B is 8 here. And side AB is alpha, which is a natural number. Cosine of A is given 2 by 3. You see how simple is this, guys? Right? Cosine of A is given. If cosine of A is given, cosine of A is 2 by 3. If cosine of A is given, it will be very simple to find out the unknown. What formula will use? Everyone can tell. If we are using any formula here, it will be cosine formula. What is cosine of A? It will be A square C square minus C square. What is that A here? A is alpha, right? Upon 2BC. So 2 into 8 into 7 is equal to 2 by 3. Right? B square plus C square. Yeah. So 2 into B is, A is, sorry, something I wrote. C is alpha. Okay. So cosine of A, B square plus C square minus A square upon 2BC is equal to 2 by 3. So B is 8, 64, C is alpha minus A square 49 upon 2BC, B is 8. So 16 into alpha is equal to 2 by 3. So we have alpha square 49, 64 is 15, right? Is equal to alpha square 15 multiplied by 3 is equal to 32 alpha. So if we simplify this, this is 3 alpha square minus 32 alpha plus 45 equal to 0. So let's simplify for alpha. This looks like a difficult quadratic, but it will simplify. So what is alpha now? So alpha is minus B plus minus root over B square. B square 32 square minus 4AC. So 4 3 12. 12 into 45. 12 into 45 divided by 2A, that is 6. So alpha is equal to 32 plus minus root over. So if you calculate this 32 ka square, this is 9 5. So kitna hoga? The 32 square, this will be 32 484. So this will be 22. This 22 divided by 6. So alpha will be either 32 plus 22 will be 54 is 9, or 32 minus 22 will be 10 by 6, but this will be rejected. Clearly it is mentioned, it's a natural number, right? So we have alpha equal to 9, we got alpha equal to 9. So we got alpha. Now what is given? You see 49, it's just calculation, nothing else, just calculation. There is no funda, it's just calculation. So 49 to cos 3c. What is cos 3c? Cos 3c will be, so first we need to find out cosine of c. So cosine of c will be b square a square minus c square divided by 2ab. right? So b square, b is 64. What is a? A is 7. So 49 minus c square. C we just calculated 81 divided by 2ab. So this is 112. What is that? This is the 64, 49 minus 81. What will be value? This 943, 113 minus 81 divided by 112. So this is the, how much? 1932, right? By 112. So this is 2 by 7. Okay, so with cosine c we have, so 49 into cos 3c plus 42 ka value we need. So 49 into what is cosine 3c? It is 4 cos cube c minus 3 cos c plus 42. So 49 into 4 cos cube c. So I think again it comes down to the calculation. You can do it yourself. Cosine c is 2 by 7. So 2 by 7 ka cube, or let's take cosine c bahar. So 49 into cos c, 4 cos square c, that will be 4 by 49 minus 3. So, and plus 42. So just complete the calculation. Whatever is the value, you know that you have to ultimately take greatest common divisor. So funda wise there is nothing. It's so simple. This is 2024 wala question. It's nothing. J cosine of A was already mentioned. So it's obviously that the unknown can be calculated super easy. Got it? Okay. So this question also, this came in 2023. Okay. This question was there in 2023. So try to simplify it. We have cos of A plus 2 cos B plus cos C equal to 2. Some sides are given. Cos of A minus cos of C is asked. Similar question, right? It's just that we have to do some mazduri. You have to square. Okay. You can try it. How to attempt it, right? Triangle ABC, cos of A. So here also we have to use cosine formula, right? Nothing else. Cos of A. So what is given? The angles of the sides opposite to the angles A and C are 3 and 7. So we are given with side length A and side length C, right? A is 3, C is 7. These two are known. So cos of A plus 2 cos B plus cos C is 2. So I think there is only one unknown, and that is B. So we can directly start with our calculation. So cos of A, it will be B square. It will be B square plus C square 49 minus A square 9. So it will be B square plus 40 divided by 2 BC. So 14B plus 2 cos B. So twice of cos B. So cos B will be A square 9 plus C square. So 9 plus 49, 58 minus B square divided by 42, right? 2AC. So it will be 42 and plus cosine of C. So it will be A square plus B square. A square is 9. So A square plus B square minus C square. So 9 minus 14, 40. So it will be B square minus 40 divided by 2AB. So 2AB, B is B, 2AB, so 6B is equal to, do you see how simple is again this is going to be? It's just calculation, guys, nothing else, nothing else. So this is B square plus 40 upon 14B plus 58 minus B square upon 21 plus this is b square minus 40. So what should we do? What should we do? So b wala part we can take common, right? 14b and 6b. So b square plus 40, these two terms. Let's simplify these two terms first. So 1 by b I'll take common. So b square plus 40 upon 14 and plus b square minus 40 upon 6. Right, so I can take 2 also common, so it will be 7 and 3. Right, and I'll send this to the other side. So it is 2 minus 58 minus b square upon 21. Okay, so 58 this minus b square 41. So now this is 1 upon 2b into, let's do the calculation, 3b square plus 120 plus 7b square minus 280. Right, 3b square 120, 7b square 280 upon 21 equal to, this is 42 minus 58 plus b square upon 21. So this 21 will cancel out. So 1 by 2b into, this is 10b square. 10b square and 120 minus 280. How much is that? That is minus 160. Right? Minus 160 is equal to 42 minus 58. So this is b square minus 16. Right? B square minus 16. So if we do cross multiplication, this is 5b square minus 80 is equal to, this is 10. 5b square minus 80 is equal to b cube minus 16b. So we have a cubic here now. So we have this cubic b cube minus 5b square minus 16b plus 80 equal to 0. So we have got a cubic, I think. Acha, we are asked cos A minus cos A. So I think we don't need to do that, right? We don't require to find value of b, because when we solve cos A minus cos C, right? When we solve cos A minus cos C, so what is cos A? Cos A is b square plus 40 upon 14b minus, what is cos C? So cos C is b square minus 40 upon 6b, right? It is b square minus 40 minus 6b. So if we do this calculation, right? If we do this calculation, so that comes to how much? If you take 1 by b common, so what is being asked? 1 by 2b. Let's take 1 by 2b common, right? So it is b square plus 40. No, let's not do this step. Let it be in this way. So it is b square plus 40 upon 7 and minus b square minus 40 upon 3. So I have taken 1 by 2b common. So 7 and 3. So this is 1 by 2b and this is 3b square plus 120 minus 7b square plus 280 divided by 21. So what we require is this 1 by 2b times, this is 120 280, that is 20 plus 18 is 28 plus 12 is 40. So 400 minus 4b square upon 21. So we take 4 common. So it is 1 by 2. So 2 by b times, this is 100 minus b square. So take 4 common, 100 minus b square upon 21. Right. So this is 2 by 21 times, if I take b inside, so 100 by b minus b. So this is what they are asking. 100 by b minus b. So if I divide b here, so this will be 10b. So this is 5b minus this will be 180, right? So I think again somewhere some calculation looks wrong here. Some step. A is 3, C was 7. A is 3, C was 7. Okay. So don't know exactly which step we have gone wrong. 2b, cos A minus cos C. A is 3, C is 7. B square plus 40. I think we need to check which step exactly we have done the calculation wrong. Okay. So fine then. So we'll start with the next topic. Till then, I'll check the calculation once. So break of some minutes we'll do. Hello, hello. Okay. Okay. So let's continue with this question. So we are getting one cubic, I think, right? So this will be, if I complete this cubic here, this will be how much? This is 5b square minus 80 is equal to b cube minus 16b. So we had this cubic b cube minus 16b minus 5b square plus 80 equal to 0. If I, this is 125 minus 80. Yeah. So this cubic, you see, because of the coefficient here, we can hit and trial with 1, 2, 3, 4, and but that will not work. So b equal to 5 will be one easy guess here. So b equal to 5 will be one very easy guess, and from that you can substitute that value here and you will have your answer. Okay. So apart from that, we can use one more way, and less calculative way it will be. Like here we have cos A, 2 cos B, cos A, right? So here what you can write is cos A plus cos C is equal to twice of 1 minus cos B. This will be cos A plus C by 2 cos A minus C by 2 is equal to twice of 2 sine square B by 2. So cos A plus C by 2 ko we can write 2 sine B by 2 also, and this will be cos A minus C by 2, and this will be 2 sine B by 2, right? So 1, 2 will cancel out from there, sine square. One sine will also cancel out. So we have cos A minus C by 2 is equal to 2 sine B by 2. Something like this, right? Once we have cancelled out. So if I multiply both sides by cos B by 2, cos B by 2, cos A minus C by 2. So we'll get 2 sine B by 2 cos B by 2. So we have cos B by 2 cos A minus C by 2 is equal to. Now this thing will be what? This is method 2, guys. This will be 2 sine A cos A sine A. This will be sine A. Sine B, sorry. This is sine B. And if I multiply to both the sides, so 2 cos B by 2 I can write, this will be pi by 2. B will be pi minus A plus C by 2, so sine A plus C by 2 into cos A minus C by 2 will be equal to 2 sine B. So 2 sine A plus C by 2 will be sine A plus sine C is equal to 2 sine B. If I multiply by 2r, so 2r sine A, 2r sine C, 2r sine B. So 2r sine A is A, so A plus C is equal to 2B. So one relation from here we'll have, so that A, B, C will be in AP. So A and C is given, right? A was 3, C was 7, so B will be 5 from here. Okay. So I blindly, if you go by calculation, you can find, or better will be by the formula. Okay. So moving to next segment, in indefinite, all the standard types, basically the substitution ones. We study a lot about all substitution forms, then the other standard forms, right? But till the time we reach reduction, right? The focus will divert, will not practice those many questions. But reduction is one of the simplest part in that chapter, and we have so many questions also which keeps repeating in JEE main, right? So I'm not going to take many examples for that. There are few which will keep on repeating. So I just want to explain, I just want you to show the process of some terms like let's say sine or tan, and from that you will relate. We'll solve some PYQ also. The reduction, what happens that we establish relation between the lower denominations. Let's say in we have integral sine to the power nx dx. Obviously, if that degree reduces, if we write in minus 1, it will be sine n minus 1, something like that. So, in here will be equal to integral sine power nx is there. So, it will be sine power n minus 1x into sine x dx. I'll split it like this. So, in reduction, what is the fundamental thing that we'll try to reduce relation between in and its lower denomination. So, here, like I'll differentiate this, I'll integrate this. So, in will be equal to, so it will be sine to the power n minus 1x into integration of sine x will be minus of cos x, then minus. So, integration will become, make it plus, then this will be n minus 1 into sine to the power n minus 2x, sine ka integration will, differentiation will be cos x, and then one more cos. So, it will become cos square x dx, correct? So, this is in is equal to minus of sine to the power n minus 1x and cos x plus n minus 1, take it outside, and here this is sine to the power n minus 2x. Cos square ko we can write 1 minus sine square x. Okay. The moment you write this, we have a very clear relation, minus this is sin x to the power n minus 1 into cos x plus n minus 1 multiplied by, you see, this will be integral sine to the power n minus 2x, split it, multiply with this 1 and this. So, minus, it will become n minus 1, again integral sine to the power nx dx. So, this is in, right? So, we will write this in is equal to minus of sin x to the power minus 1 cos x and plus, this is n minus 1 times. Now, this is what? If it is in, we have sine power n, so this will be in minus 2 and minus, this is the original one in. So, take this term into LHS. So, in and n minus 1. So, n times in, and take it this side, minus n minus 1 times in minus 2 is equal to minus sin x to the power n minus 1 into cos x. So, you see, we derive this relation, and here if we have some limits 0 to pi by 2 or like that, so the terms will reduce further, we'll have a better relation. So, in integration by reduction, this is what we always try to do. We try to derive relation between n and its lower denomination, and the process is almost similar in all the formats, right? Sometimes, like, you will always have this idea that what to segregate, right? Like, you know that you have to reduce. Like, here you will not try to integrate something else. You will not try to write sin x into 1, because that will create x which has no relation with in. We'll try to have only those terms which can be written in terms of the given integration. We'll not take x here, right? So, ultimate target is these kind of relation, right? And here again we can keep on reducing this. So, one more example I'll take, very easy and multiple times used, that is integral of tan to the power nx dx. So, for tan, though, it's in fact it's easier to guess that what should be done. So, we can write integral this as tan n minus 2x into tan square x dx. Okay. So, in will be equal to integral, this is tan to the power n minus 2x, and tan square x I can write sec square x minus 1 dx. So in will be here now integral tan to the power n minus 2x into sec square x and minus integral tan to the power n minus 2x. So clearly we have reduced this to n minus 2. So we have in, we have in minus 2, and this is integrable form. What to do? Take tan x as t. So if you take tan x as t, sec square x dx will be dt. So in will be equal to integral t to the power n minus 2 minus I n minus 2. So we have this very simple relation that in plus in minus 2 is equal to t to the power n minus 1, that is tan x. So tan x to the power n minus 1 divided by n minus 1. This is it. This is the final result. So in almost all reduction questions, this is our target, that we try to segregate in such a way that we have either integrable form, or if we are using by parts, it should be in such a way that we reduce the degree. So this question you can do on your own. This is pi by 4, so pi by 2, cot to the power n. Similar approach with cot, right? Cos x square minus cot square x is 1. Exact similar 2021. Even before that also this question has been asked, right? So this I'll keep it as a homework for you. So please do attempt this. Then next question. This question is something which has been asked recently, so I'll explain this. And in this also the reduction will strike very easily. You see this in here, in is written integral 0 to 1 minus x to the power k whole to the power n dx. So here already we are doing integration in algebraic terms. So definitely I don't know how to integrate any of this here. So here I'll take help of 1. I'll write 0 to 1 minus xk to the power n into 1 dx. So this thing will be differentiated and this thing will be integrated, right? K is a constant here. So now this here term mentioned was already algebraic, so that is why I have written like this. So now let's move further. So in. So what will be in? So in will be equal to integral 0 to 1. Okay, so let's do the by parts here. So 1 ka integration will be x to 1 minus x ka power k to the power n into x, and in this limit will be from 0 to 1, then minus integration 0 to 1. So integration is x. Now differentiation of 1 minus x k to the power n. So it will be n into 1 minus x ka power k to the power n minus 1. Then 1 minus x ka power k ka differentiation will be minus of k, minus of kx into x ka power minus k into x ka power k minus 1 into dx. So if we substitute limit, guys, this will be 0, right? This will be 0. So this minus ka plus ho jayega. So integral 0 to 1, this is n into, or k also we can separate. So k into n, integral 0 to 1, right? 0 to 1. This is x ka power k minus 1 multiplied by this will be x ka power k again. So 1 minus x ka power k n minus 1, and minus it became plus. So we have x ka power k again, right? I hope it is correct. Yeah. Okay, into dx. So we have reached up to this step. Now what to do? Is do plus 1 minus 1, right? So in is equal to minus kn. I multiply inside 0 to 1 minus x ka power k to the power n minus 1 into 1 minus x ka power k minus 1 dx. So in is equal to minus k into n. So when this will multiply, it will be 0 to 1 minus x ka power k to the power n, and then plus this will be kn. this will be minus minus plus kn integral 0 to 1 1 minus x ka power k to the power n minus 1 dx, right? So this whole thing will multiply with this and this. So clear terms we have reduced, right? It is dependent on n, not on k. So in is minus kn into, what is this, guys? This is in again, and plus this is k into n into, this whole part is I n minus 1. So we have very easy relation here, in into 1 plus k into n is equal to kn into I n minus 1. So we can write that in upon in minus 1 is equal to kn upon 1 plus k into n. Okay, so we have got this value. So now this is what? This is already given. I20 upon I21. We are given I20. So put n equal to 21. So if I put n equal to 21, I will have here I20. So k into 21 upon 1 plus 21k is equal to 147 upon 148. I21 is 147, 148. So I think it will cancel out, right? This is 21 into 7, and so 148k is equal to, this is 7 plus 147k. So clearly value of k will be 7. So see, this is not something which is very difficult to predict, right? If I talk about regular class notes, whatever you have been taught in class, or whatever standard illustration you might have done in your practice or any via test papers, this is what we see most of the times. You see here, one thing I have done, that is addition, subtraction of plus minus 1. This step, right? For JEE main, I can certainly tell you that nothing apart from this will be there in exams, right? That's it. They don't emphasize too much on this. It is always plus minus 1 or very, very simple manipulation, right? And the other one will be the trigonometric one, maybe sine, cos, tan, cot. So this also you can try on your own, and you know what to do. This is cot to the power nx. You know how to attempt it by writing cot in terms of cosec. Okay. So we can have further discussion. Okay. Yeah. So now talking about the ITF part. So in ITF these days the syllabus has been reduced further, that is clear. But again, the formulas, the basics you have to know, right? The formula which is of cos 2 theta, sin 2 theta in terms of like inverse, those results are must to remember. Now even though in exams, like, it feels like the most of the questions are not from that segment, but if I see some PYQs, right, I'll show you some PYQs. You see in recent years, you see these questions, right? So these all are the most basic application of T inverse and T. So I hope you know how to attempt these all. For all these kind of questions, the property should be on your fingertips. Every single property you have to know, and these are something which, like, it is always excluded. Now talking about the range thing, like some students, they will blindly believe that the range which has been given falls on the standard one, the easiest formula that you have done, but it won't be the always thing. So the derivations are must. You have to have your basics very clear, especially about the 2 theta and 3 theta results. So like for one, I'll let's try this. The cos inverse 2x 1 minus x square. X is given minus 1 by 2 to 1 by 2. So how exactly we approach these kind of questions, right? Because we can clearly see that these all results are somewhere related to those T inverse T derivations. So like for now, like here also, if you see what kind of substitutions we do. So it's always the substitutions. The main idea is substitution. You will always know. You will always know what exactly to substitute. Like here, like for this example, if I ask you, okay, what exactly we should substitute, moment you will see cos inverse, you will say, okay, sir, let's put x equal to tan theta, and that is correct. So now, okay, you know the substitution, but don't always assume that the given range of x will take you to the standard one, right? This much, see, ITF is a very small chapter, and these derivations are not something which is like beyond your ability. It's very simple. So what I'll recommend that do attempt these derivations at least for once, all the formulas for 2 theta at least, right? When we write for this cos inverse 1 minus x square 1 plus x square, if I write formula for this, so we know that this is either plus 2 tan inverse x or minus 2 tan inverse x, right? This particular result is either plus 2 tan inverse x or it is minus 2 tan inverse x. So when it is 2 tan inverse x, when x is greater than 0, when x is less than 0. Ideally, I will assume that you remember the result along with graph. This is how the graph looks like. Non-differentiable at x equal to 0. But I can understand not everyone will remember, but the derivations are important, right? So here, now x is given between 0 to 1, right? So if you remember the result, fine, you can write direct result that this is 2 tan inverse x. From here, you can simplify. Here also we can substitute the same x equal to tan theta, and this converts into the formula. So the simplification will be easier. But let's say if you don't remember, then do the substitution and just get started. So you know that x is tan theta. So this is 2 tan inverse 1 minus tan theta upon 1 plus tan theta equal to cos inverse 1 minus tan square theta upon 1 plus tan square theta. So we know that x was tan theta, so we already know that where exactly theta lies. Theta, x lies between 0 to 1. So that means that the angle theta lies between 0 to 45. Right? The angle theta will be between 0 to 45. So this is 2 tan inverse. What exactly is this? This is tan 45 minus theta. Right? And the RHS is cos inverse. This is cos 2 theta. Correct? Now, this is T inverse T function, right? So for both we know the range. For cos it is 0 to pi, for tan minus pi to pi by 2. So let's check. Pi by 4 minus theta. So theta minus theta will be from minus pi by 4 to 0. So if I add pi by 4 here, there will be no issue. It will be from 0 to pi by 4, right? Theta is 0 to pi by 4. So minus theta will be minus pi by 4 to 0. If I add pi by 4, 0 to pi by 4. So this looks completely fine. We can write directly twice of pi by 4 minus theta. What about this side, guys? So theta is between 0 to pi by 4. Theta is 0 to pi by 4. So 2 theta is between 0 to pi by 2. And we know that cos inverse cos x is x when x is between 0 to pi. So it falls in the perfect range. So this will be only 2 theta. So we have pi by 2 minus 2 theta equal to 2 theta. So 4 theta equal to pi by 2. Theta will be pi by 8. Now the point is, see. So the point is that all these cases like here, whatever you are going to see in JEE mains, most of them have very easy logic of substitution, right? So my recommendation will be that just go and revise all the derivations once more before you attempt your exams, especially these results, guys. 2x 1 minus x square, tan inverse plus cot inverse x, right? These are not something which is very difficult to understand. Cot inverse, you know the substitution here, already x is given. You see here, when you put x equal to from minus 1 to 1. So x is tan theta, so theta we have taken from minus pi by 4 to pi by 4. This will convert into 2 theta. So falls in the perfect range, that is clear. But for cot inverse, you see, it will be opposite. So do try these derivations at home and make sure that you don't do any mistake in ITF chapter. So these were the some questions which I had thought that I'll explain. There are some questions which I have left for you as a homework. So do complete that, and best of luck for your JEE Mains exam.